था ऊंचा, बंदे हम सफर बेचारे। अब बंदे हम सफर बेचारे, लड़के लोग मसल बेचारे, लड़के लोग मसल बेचारे, बंदे हम सफर बेचारे। कभी कभी सोचता हूँ, यादों का सुना था, कोई देखा ही नहीं, मैं पापों का। There is a numeric keypad on a mobile phone. You can press the current button or any button that is directly above, below. Press 5 and pressing 2, 4, 6, 8. Pressing the row corner button. One button on the keypad. लड़के सब मसल तो चारे। वन में 2+3 करेगा तो 4 आएगा, 2 में 2+3 करेगा तो 5, -1 +1 -3 ऐसे करेगा। दंग 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 दंग। टोटल 12 बटन है ना। कोई नहीं पूछता। तो अपन स्टार और हैश को भी नंबर दे देते, 10 और 12 लिख देते। बेस्ट इन द बिज, है ना। कर तो सकते हैं। आओ फिर, आओ फिर उस दिन पार्टी जल्दी से मैं जाने में एना के पानी तो पहना सकते हैं। देखो अगर तुम्हें अप जाना है तो -3 कर दो, तो राइट जाना है तो +1 कर दो, लेफ्ट जाना है तो -1 कर दो, डाउन जाना है तो +3 कर दो, इजी। हमें कुछ नहीं करना, एक फॉर लूप चल, कहाँ से कहाँ तक चलता है ये पहले एक से लेस देन इक्वल टू बराबर आई प्लस प्लस। ओके, then we'll go by कोई नहीं पूछता, गला दो क्या गला तो सूखा, मैं गले में सूखा और सौ ख्यालों में डूबा, कोई मदद नहीं पूछता। सड़क का ऊंचा, लगे ये सफर पे जा रहे ना 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 अबे तुम वन थ्री टंग 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 If you press 5, then pressing 2, 4, 6, 8 is allowed. However, diagonal mention pressing the yeah. 0 और 8 क्यों है यहाँ पे सिर्फ 0 के लिए from 0 0 0 0 8 हाँ तो वही है Okay. कोई नहीं पूछता मेरा दिल क्या मेरा तस्वीर गले में सुनता सब ख्यालों में घूमता कोई नहीं पूछता लग गए सफर पे जा रहे यार मोहब्बत में जा रहे कोई नहीं पूछता गला गला सीखा गले में सुनता सब ख्यालों में घूमता कोई नहीं पूछता सड़क पे कर रहे बिजनेस कितना गली में सुनता और साफ ख्यालों में कोई मदद नहीं पूछता ऐसा ये कर लेकिन मैंने जीरो idea is greater than rake dapede itu dapede dapede bagu timely not invited plus 3 years which is 9 plus 3 less than 0 नहीं होना चाहिए और 0 नहीं होना चाहिए कोई नहीं पूछा बुरा था अलग दूसरा गली में सुन था क्या ख्याल में था कोई नहीं पूछता बैठा ये सर पर बनना ना झुकता मैं गली में सुन था मेरे साथ तेरे में दिन था सड़क था ऊंचा मैं ये सफर गुजारा 5 बार लिखने से अच्छा मैं फॉर लूप में चलाऊंगा क्या क्या बोले चलो 3 1 -3 Reaction 0 and 0 जीरो का अगर तो भी गलत है अपन जीरो रख ही नहीं रहा है हम इसको 11 जोड़ेगा जो 11 11 -3 करेगा 11 में 11 में -3 करेगा 3 10 किया 12 किया सबके लिए गलत है फिर -3 के लिए सही कड़क कड़क है कड़क है कोई नहीं पूछता बुरा था वक्त और गला बस सूख रहा मैं गली में सुनता मैं ख्याल में घूमता हूँ पूछता सड़क पे कर ले बिजनेस खुद का गली में सुनता ख्याल में घूमता सड़क था ऊंचा सड़क था बूंदा लड़के ये सफर पे जा रहे लेकिन मोहब्बत की खेल 0 so sorry about that hey very sorry on my lap hey so so sorry about that yeah, very sorry on my lap so sorry about that hey very sorry on my lap so so sorry about that नारंगी रे हो ओ ओ तुरुरुरु, तुरुरुरु, सतरंगी रे हो 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 एक दिन दोनों तुझसे तुझसे दोनों तुझसे दोनों तुझसे तुझसे नीचे तीन आएंगे फिर फोर पे जाता है। ठीक है, पहला दबाया, अब चाहो छोड़ कर के अगर वन में इधर ही कर दे रहा हूँ तो मुझे एन माइनस वन में लिखना चाहिए। और यहाँ पे मुझे आई भी देना चाहिए। एक हो गया। लड़के हम सब करते जा रहे हैं। अब अगर मैं एक भेज रहा हूँ, हाँ, यहाँ पे एन माइनस वन भेजना नहीं चाहिए। ओ भी ना चाहो छोड़ कर के दिल अभी तेरा नहीं 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 खुदा मैं हूँ पर खुदा जाओ तेरे पर नशे के साथ ये पल यही कहावती सदा के दो उन्हें खाना मेरा नाम देता ऐसा है याद नहीं समझ गया। तो जब फोर आएगा ना ये से थ्री आएगा ना तो थ्री के राइट में नहीं जा सकता, थ्री राइट में नहीं जा सकता और फाइव जा सकता है ऊपर नीचे। तो फोर सिक्स दे कांट गो राइट, है ना। ये दिक्कत दिक्कत है इसमें ये मेरे सारा परसेंटेज दीपक फेल है ना। ये तो हो तो जाएगा पर से अगर राइट जाना हो तो राइट कौन कौन जा सकता है? वन टू फोर फाइव सेवन एट, ये सारे राइट जा सकते हैं। ऊपर जाना है 47586 अब लेफ्ट जाए 326598 तो ये तो सिस्टम हो गया ना पूरा कैटेगराइज करना पड़ेगा मुझे थोड़ा सा तो कुछ नहीं कैसे जा रहा 1 सम प्लस इक्वल टू मुझे ये तो करना ही है तो इसमें कोई दिक्कत नहीं। क्या करना है आइडिया पॉजिटिव बोलते हैं 124578 राइट हुआ तो ये सेट लिखेंगे इंटीजर राइट वाले वाले कौन कौन कर सकता है राइट राइट डॉट फाइव सम प्लस इक्वल एक्स कौन एन प्लस बन जा सकता है बदल अब वैसे ही अपने को ऊपर वाले बनाना पड़ेगा समझ रहे हो ऊपर वाले में कौन कौन है ऊपर में कौन कौन जा सकता है फोर फाइव सिक्स इलेवन oopsie oopsie so 4 5 6 7 8 9 11 तीन चीज करेंगे ये और ऊपर वाले ये डब्ल्यू अब ज्यादा एफर्ट नहीं डालना ये अब सिमिलरली नीचे वाले बनाना है क्या बनाना है नीचे वाले इसके जस्ट नीचे बनाना नीचे कौन कौन चलो नीचे जा सकता है 1 2 3 4 5 6 और 8 +3 तक है तो कुछ नीचे वाले हो गया सेम चीज यहाँ पे अपने को कॉपी करने का पेस्ट कर तो नीचे वाले नीचे वाले ऊपर वाले के लिए क्या करना है -3 कर देंगे नीचे जाने के लिए क्या करना पड़ता है +3 कर दिए अब राइट वाले का लेफ्ट वाले बनाना है बराबर लेफ्ट वाले LW लेफ्ट में कौन कौन जा सकता है 2 3 5 6 8 6 8 9 बराबर बराबर क्या कर रहा है सेम चीज नीचे वाले के लिए कर दो सॉरी लेफ्ट वाले लेफ्ट वाले तो अभी अगर 5 आएगा तो है जगह अगर 9 होगा तो ऊपर वाले और लेफ्ट वाले में ऊपर वाले और लेफ्ट वाले में मोहम्मद अब्दुल मोहम्मद अब्दुल नवाज हेलो भाई ओला अमीगो ओला 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 जैसे ही ये खत्म होता है, मेरा ये वाला चीज उसके बाद वही करेंगे, क्या बोलते हैं, फिर वो जाके मजा आ जाएगा। ये सही है क्या भाई, देखते हैं कैसे। Expected is 532 और मेरा भी यहाँ पे नहीं है, ब्लेंड कुछ होगा। तो इसलिए नहीं हो रहा है क्योंकि सॉल्व नहीं लगा, तो वही बात, इतना सही है। Let's check. Oh, हुआ। ओके, रिजॉल्व तो हुआ, पर हम इसको ये करने वाले। तो कुछ ओके, ये लिया है भाई। वो इसको मैं रजिस्टर करता हूँ, कैसे करेगा? मेरा माइक चल रहा है। ओके, तो लेट्स स्टार्ट। तो लिखेंगे जस्ट सड़कों पे घूम रहा। क्या बोलते हो, अब हो जाएगा? या तो कितनी गेली दो जाएगी? हो गया। You are given a Boolean expression as containing a kind of point of question. Count the number of ways we can identify the Louisiana. आज खुदा भी यारा शुक्र है तो ऐसा शुरू। अच्छा सवाल है भाई। क्यों? मुझे पार्टीशन वार्टीशन वाला इशारों इशारों बोलने वाले बताए तुमको लेट्स सी। थोड़ा हाथ पैर चलाते हैं, देखते हैं कुछ होता है कि नहीं होता। बुक और पेन निकालते हैं। पीरी 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 पेरी पेरी पीरी पेरी। With 358 new subscribers, ये तो सही नहीं है, ये तो सही नहीं है. ये टी नहीं आ रहा. या तो इसके दो तरीके हैं. अगर चार दिए हो तो ऑपरेटर तीन दिए. इसमें के बीच में पहले दिया. सिर्फ टी का ये फर्स्ट आने का यूज है. ऐसे नहीं जो नहीं समझ आ रहा.
देखो मैं क्या लाया, न्यू शूज। हम उन्हें अपने जैसा समझते हैं।
Hey everyone, welcome back to Take You Forward. So today we will be solving the problem Boolean evaluation to true. Now this is again a similar problem related to MCM DP. So if you have not seen the MCM lecture, go back, watch DP 48, 49, 50, 51. Make sure you watch out all these 4 lectures and then you can definitely watch out Boolean evaluation because this problem is so much related to MCM. Like if you know MCM, this problem becomes like a cakewalk. So please go back and watch it. Now what does the problem state? Let's understand the meaning of the problem. So the problem states you'll be given a string, okay? Now this is the string that is given to you. And the string you'll be given true or false and then an expression. Now the expressions can be or, which goes by this, and which goes by this, and Zor, which is somewhat like this. So these are the 3 expressions that you will be seeing all over. Now imagine I give you this particular expression. Now the standard way to solve this is you can go anywhere, like true and true, like you can probably write true and true is true, and false, which gives you false. This is one of the possible ways where you say true and true is true, and then true and false is false. Thereby this is false. So this is one of the ways. But what they want you is to perform this, like to solve this in such a way that at the end of the day you get true, that at the end of the day you get true. So for an example, what I can do is, see, I can probably say I'll keep t, then I'll keep or, and then I'll perform this portion at first, like I'll perform this portion at first. So if I perform this portion at first, we will get false, true, or false, which gives you true. So this is one of the ways in which you can definitely, yes, in which you can definitely get true. So I can say for this expression, I have one way in which I can get true. So do I find any other way? No. Since you're not finding any other way, you have to just print one. This is nothing but the number of ways in which we can evaluate it to true. Okay. Now let me just quickly take one more example and try to explain you. So let me take one more example, this expression, and try to solve it. So imagine I say that I will be solving f or t at first, then I'll be doing a solve with f. So f or t will give you what? It will give you true, definitely. Trues or f will give you true. So if I follow this pattern of solving, I'm still evaluating this expression to true. Now if I go in the other way where I say, okay, listen, let's keep this and let's try to solve t XOR f at first. Now true XOR f will be nothing but trues, and then there will be an f which again gives you true. So if I follow this way and this way, I'm still getting a true. If I follow the other way of solving this first and this, then also I'm getting a true. So I can say there are 2 ways in which I can evaluate this expression to get true. There are 2 ways in which I can evaluate this expression to get true. So the question is very straightforward. The question states, given an expression, you have to tell me the total number of ways. You have to tell me the total number of ways in which you can evaluate this expression to true. Okay. So how do you solve this problem? How do you solve this problem? Again, isn't it like you definitely know it will have true, then it will have probably XOR, then it will probably have false, then it will probably have or and, then a true probably, then an and, then a false, then a XOR, then a true. Like it can be anything, but something for sure you know is it starts with a true or false, and then it's followed by an operand, then followed by a true or false, followed by an operand, followed by true or false, followed by an operand, followed by true and false, followed by an operand, followed by true and false, followed by an operand. Something I definitely know is either I solve this guy at first and then this. Then over here I can decide whether to solve this or that. That is a different thing. But when I start, can I think this problem in this certain way that either I solve this and this, or either I say this or 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 this. So can I say at every operand, certain way that either I solve this and this, or either I say this or 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 this. So can I say at every operand, I can do a partition stating I solve the left subproblem, I solve the right subproblem. right? Or I can say on this operand, I solve the left subproblem and the right subproblem. Or I can say on this operand, I solve the left subproblem and the right subproblem. Or I can say on this operand, I solve the left subproblem and the right subproblem. Or I can say on this operand, I'll solve the left subproblem and the right subproblem. So on every operand, I'm actually breaking it down into subproblems. And then imagine if I'm solving this, this will give you a true. And then on this, like if I try to write this subproblem, like if I just do it in yellowish, F or T and F XOR T XOR F. Now on this, again you can do the same thing. Either you solve this and this, either you solve this or this, either you solve this or this, either you solve this or this, and again this will be solved. So am I getting a pattern of breaking it down on the operand? Yes, I'm getting a pattern to break it down on the operand. So why don't I break it down on the operand? Let's actually break it down on the operand. So can I say initially I have this entire expression to be solved. So probably we know this is nothing but similar to something like MCM where we had A B C D E F. We decided this will be solved at first and this will be solved at first. So can we actually think this problem in that direction? We definitely can, and that is what we will move across and try to think. So can I say initially I have this entire range. I can call this as I and J as we have been doing in all the other problems. I can say this is the entire range that I'm looking to evaluate, right starting from the true to this last guy. I can say this is the initial range that I'm looking to evaluate. Now can I say if I'm standing at I can always do a partition on an operand, on an operand, on an operand, on an operand, on an operand. I definitely can do, and that operand can be this guy, this guy, this guy, or this guy, or this guy. Do you see a pattern evolving? Do you see a pattern evolving? Yes. The operands are at a distance of 2 indexes. The operands are at a distance of 2 indexes. I can definitely vouch for that the operands are or will always be at a difference of 2, right? And if this is the entire expression that we are solving, the first operand will be starting from I plus 1, then you can do a plus 2, then you can again do a plus 2, then you can again do a plus 2 in order to find your operands, and you can go on till j minus 1 because that is where the last operand will be. So I have practically understood where can I do a partition. That is definite enough that where can I do a partition. But now how do I solve the problem? Imagine, let me just erase this blue lines because those are a lot of lines. Okay, now this was the entire range, right? Imagine I'm doing an operand, like I'm trying to do a partition here. This is an AND operator. This is an AND operator. So apparently, this is the subproblem that I'm saying to solve. This is the subproblem that I'm saying to solve. Correct? So if this partition is done at an like I need to solve this partition, which is f of I comma index minus 1. This belongs to this, and this is nothing but f of index plus 1 comma j as usual. This is a left subproblem. This is a right subproblem. Now, since there is an AND operator, what should the left subproblem give you back? What should the left subproblem give you back? And what should the right subproblem give you back? That is a simple enough question that I'm asking you. So we know that if there's an AND operator, and we know AND will, because you are saying there's a left guy, and there's an AND, and there's a right guy. So I know one thing for sure, this left has to yield a true. This left has to yield a true, and this right has to yield a true. That is for sure. The number of ways, can I say, since I'm looking for the total number of ways to make true, can I say the number of ways in which the left yields true? Imagine it is x number of ways, and the number of ways the right yields true is y. So can I say the total ways will be x into y, where x is the number of ways in which the left guy gives true, the left is true, and similarly y is number of ways in which the right is true. Understood? So that was for AND operator. That was for AND operator. Now similarly, if I think of other patterns where we are doing a partition at, imagine OR, and there's a left guy that has to be solved, and there's a right guy which has to be solved. So if it's an OR operator, when does an OR operator gives you a true? Like when will this yield a true? Can I say if the left subproblem yields true and the right subproblem yields a true? And imagine this is x1 ways, this is x2 ways. The left subproblem yields true or gives you true in x1 ways. The right subproblem gives you true in x2 ways. So can I say the number of ways will be x1 into x2? Is it just limited to true? No, because it is an OR operator. So I can say if the right yields false in x3 ways, because this right subproblem might also give you a false, might give you a false. And if the number of ways in which it gives you a false is x3, so what you say is, hey listen, there is true on the left, there's false on the right. So true and false, if it's an OR operator, will also yield a true. True or false will also yield a true. Thereby the number of ways can also be x1. The number of ways in which you can make true on the left, the number of ways in which you can make false on the right. Similarly, can I say, if I make false in x4 ways, I can again say false from here, true from here will also yield a true. Thereby x2 into x4. So I can say the total ways will be this. I figure out the number of ways of true, the number of ways of true, number of false, false, and total will be this if it's an OR operator. If it's an
अरे ये क्या है?
Red Bull. It gives you wings.
Wings. अब रेंगने की जरूरत नहीं.
Try करके देखो.
या तो ये wings वाली बात बेकार है, या फिर मैंने कोई गलती की होगी.
It's a simple and it's an easy one. It is just x into y. If it is OR, then it becomes x1 into x2, x1 into x3, x2 into x4, right? And similarly, if it's a XOR, let's understand when does a XOR gives you a true. So XOR is basically if it's a true or true, it will give you a false. If it's a false or false, it will give you a false. If it's a true or false, it gives you true. If it's a false or true, it gives you true. So these are the ways in which it can yield true. Remember this. Now I see one thing. Only there are two ways in which you can get true. So thereby, if there is a left subproblem, if there is a right subproblem, and if I can get the number of truths to be x1, the number of truths to be x2, the number of false to be x3, the number of false to be x4. So I can say it's true into false, which is x1 into x4. That's true into false, and false, which is x3 into true, which is x2. So for the XOR, whenever the the number of false to be x3, the number of false to be x4. So I can say it's true into false, which is x1 into x4. That's true into false, and false, which is x3 into 2, which is x2. So for the XOR, whenever there is a XOR operator, this will be the total number of ways. This will be the total number of ways. So I can understand one thing. If I'm solving a left subproblem, I have to figure out the number of ways in which it can be true and in which it can be false. So I have to solve it in two ways. I have to figure out in how many ways it can be true, in how many ways it can be false. Understood? Now, as of now, we were just solving a two problem where we are given a range ij and we're trying to evaluate it to true. But now, whatever range, because this is a problem and this is a problem, this might yield a true, this might yield a true, or this subproblem might be a false. So whatever range I'm solving, yes, whatever range I am solving, I need to figure out in how many ways it can be made true, in how many ways it can be made false. So I'm looking to make it true, or I'm looking to make it false. I have to figure out both the ways. So apparently, can I just carry a third variable? I can. So what I'll do is, I know this is the range that I'm looking to solve, and I will say 1 or 0, like true or false, is true. Like, are you looking for true? So I'll have this guy is true. If I'm looking to figure out the number of ways in which I can need to have it true, I'll have it as 1 or I'll have it as 0. Like initially when you start, let's go back and understand. Initially this is the guy, and if I try to write down the indexes, it's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I will call it f of 0, 10 because the range is from 0 to 10. So I'll call it 0 to 10. And this is the initial expression. And the question states, in how many ways can you make the initial expression true? So I will call is true as 1 because I'm looking for true. Because I'm looking for the number of true, so I'll call it as 1. Got it? So what I'll do is, I will simply have it as is true. And initially I will start off with f of 0, n minus 1 and 1 because I'm looking for the number of truths. I'm looking for the number of ways in which you can make true the entire line, the entire stuff. So that's why I initially start with 1. But whenever you're solving the left and right subproblem, make sure you take care of whether you need true or whether you need false. Got it? So what will be the base case in partition DP? Now you know one thing for sure, if the partition is over, which is this case, I greater than j, this is partition over. And there are 0 ways in which you can make it true. If there is no partition, there is no true or no false. So you just return a 0 as a standard way. What's the other way? Now when do you actually get it true and false? Try to realize, try to think. So imagine if I'm just giving you this portion, true or false XOR true. Imagine. Now whenever you're trying to solve this subproblem, at play, this was the initial subproblem, I and j, and then you broke it down into solving, saying just solve this, where I is this, j is this, and also solve this f XOR t, where I is this, j is this, and the other
I
way you're
equal
saying
to
solve this subproblem where I is this, j is this, and solve this subproblem where I is this, j is this. Now tell me one thing. If this is a subproblem where I and j is he himself, where I and j is he himself, what will this guy give? This guy
C
will give
only
one way to make it true. This
one
guy will
way.
give one way to make it true. Since I was looking to make this guy as true, this will give true as one way because I is equal to j and it was true. Similarly over here, single guy, this will also give you one way. So can I say if I is equal to j, then that is when I can say it's end. If the single guy, you know it's a true or false. If the single guy, it will either be true or it will either be false. The single partition will either be true or false. And if your is true is looking for 1, like if you're just looking for 1, if you're passed on 1, which means you're saying how many truths are there, in how many ways can you make it true? You will say, okay, if is true is 1, then I will return you whatever is at my partition. If that is true, I'll return a true, or else it will return a false. This will make sure that it returns a 1 if true, 0 if false. Remember this. And if it is not, if is true is like you're looking for false. If you're looking for false, remember this. If you're looking for false, in how many ways can you make it false? Then I will say, okay, then kindly return if the partition is false, then only return 1. If the partition is false, return 1 if false, return 0 if true. So in this way, number of ways in which you can make true the entire guy. 10. So I will call it f of 0 comma 10 because the range is from 0 to 10. So I'll call it true. I'm looking to make it false. I have to figure out both the ways. So apparently, can I just carry a third variable? I can. So what I'll do is, I know this is the range that I'm looking to solve, and I will say 1 or 0, like true or false, into x4, that's true and false, and false, which is x3, into 2, which is x2. So for the XOR, whenever there's a XOR operator, this will be the total number of ways, this will be the total number of ways. So I can understand one thing. If I'm solving a left subproblem, I have to figure out the number of ways in which it can be true and in which it can be false. So I have to solve it in two ways. I have to figure out in how many ways it can be true, in how many ways it can be false. Understood? Now, as of now, we were just solving a true problem where we are given a range ij and we're trying to evaluate it to true. But now, whatever range, because this is a problem and this is a problem, this might yield a true, this might yield a true, or this problem might be a false. So whatever range I'm solving, yes, whatever range I'm solving, I need to figure out in how many ways it can be made true, in how many ways it can be made false. So I'm looking to make it true, I'm looking to make it false. I have to figure out both the ways. So apparently, can I just carry a third variable? I can. So what I'll do is, I know this is the range that I'm looking to solve, and I will say 1 or 0, like true or false, is true. Like, are you looking for true? So I'll have this guy is true. If I'm looking to figure out the number of ways in which I can need to have it true, I'll have it as 1 or I'll have it as 0. Like initially when you start, let's go back and understand. Initially this is the guy, and if I try to write down the indexes, it's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I will call it f of 0, comma 10 because the range is from 0 to 10. So I'll call it 0 to 10. And this is the initial expression. And the question states, in how many ways can you make the initial expression true? So I will call is true as 1 because I'm looking for true, because I'm looking for the number of true. So I'll call it as 1. Got it? Perfect. So what I'll do is, I will simply have it as is true. And initially I will start off with f of 0, n minus 1 and 1 because I'm looking for the number of truths. I'm looking for the number of ways in which you can make true the entire guy, the entire stuff.
got it.
So that's why initially start with 1. But whenever you're solving the left and right sub problem,
ये
make
वो
sure
है कि
you
अपने को
take
चाहिए क्या? By 360 subscribers.
care of whether you need true or whether you need false. Got it? So what will be the base case in partition DP? Now, you know,
XXX XXX Fantasian song.
one thing for sure, if the partition is over, which is this case, I greater than j, this is partition over. And there are 0 ways in which you can make it true. If there is no partition, there is no true or no false. So you just return a 0 as a standard way. What's the other way? Now, when do you actually get it true and false? Try to realize, try to think. So imagine if I'm just giving you this portion, true or false XOR true. Imagine. Now, whenever you're trying to solve this subproblem, at like this was the initial subproblem, I and j, and then you broke it down into solving, saying just solve this.
अब जो ये जो मेरा ट्रू है ना, ठीक है, वो ट्रू होने के चांसेस कितने हैं और फॉल्स होने के चांसेस कितने हैं? तो अगर मेरा इज टू 1 होगा और मेरा ए आई इक्वल टू जी होगा ना, तो अगर मैंने स्ट्रिंग ऑफ आई, अगर इज टू 1 है और स्ट्रिंग ऑफ आई इक्वल टू ट्रू है, वो रिटर्न करना है। पर अगर इज टू फॉल्स है तो स्ट्रिंग ऑफ आई इक्वल टू एफ रिटर्न करना है।
Where I is this, j is this, and also solve this f XOR t, where I is this, j is this. And the other way you're saying, solve this subproblem, where I is this, j is this, and solve this subproblem where I is this, j is this. Now tell me one thing. If this is a subproblem where I and j is he himself, where I and j is he himself, what will this guy give? This guy will give one way to make it true. This guy will give one way to make it true. Since I was looking to make this guy as true, this will give true as one way because I is equal to j and it was true. Similarly over here, single guy, this will also give you one way. So can I say, if I is equal to j, then that is when I can say it's an end. If the single guy, you know it's a true or false. If the single guy, it will either be true or it will either be false. The single partition will either be true or false. And if your is true is looking for 1, like if you're just looking for 1, if you're passed on 1, which means you're saying how many truths are there, in how many ways can you make it true, you will say, okay, if is true is 1, then I will return you whatever is at my partition. If that is true, I'll return a true, or else it will return a false. This will make sure that it returns a 1 if true, 0 if false. Remember this. And if it is not, if is true is like you're looking for false. If you're looking for false, remember this. If you're looking for false, in how many ways can you make it false? Then I will say, okay, then kindly return if the partition is false, then I'll return 1. If the partition is false, return 1 if false, return 0 if true. So in this way, you can say that partition at the end of the day is true. If you're looking for true, it's one way. If you're looking for false, it's one way. Otherwise, it's not. So this is how the base case can easily be written. Once you have written the base case, we will get back and see, okay, where is the partition? Now, where can you make the partition? If this is I, this is j, I already told you. You start from I plus 1 and you go until j minus 1 with a transition of plus 2, plus 2, plus 2. So just go across and make the partition. So what you'll do is you'll just go across and try to make the partition, right, starting from index equal to I plus 1, index lesser than equal to j minus 1, and index equal to index plus 2, you'll always make a jump of plus 2. So imagine I'm saying x1 is the number of ways in which you can make the left partition true. Or let's have it a name better. Left partition can be made true in the number of ways as I comma n minus 1 is the left partition. I'm looking the left partition to be true. So 1, the left partition can be made false in I comma n minus 1 comma 0. The right partition can be made true in index plus 1 comma j can be index equal to I plus 1, index lesser than can easily be written. Once you have written the base case, we will get back and see, okay, where is the partition? Now, where can you make the partition? If this is I, this is j, I already told you. You start from I plus 1 and you go until j minus 1 with a transition of plus 2, plus 2, plus 2. So just go across and make the partition. So what you'll do is you'll just go across and try to make the partition, right, starting from index equal to I plus 1, index lesser than equal to j minus 1, and index equal to index plus 2. You'll always make a jump of plus 2. So imagine I'm saying x1 is the number of ways in which you can make the left partition true. Or let's have it a name better. Left partition can be made true in the number of ways as I comma n minus 1 is the left partition. I'm looking the left partition to be true. So 1, the left partition can be made false in I comma n minus 1 comma 0. The right partition can be made
Right
true in
partition true.
index plus 1 comma j is the right
Index
partition
plus 1
comma
comma j.
1. The right partition can be made false in. You can go to the right partition and say, can you please bring me down? So depending on if you want a true, you send in a 1. If you want a false, you send in a 0. If you want a true, you send in a 1. If you want a false,
और अब अगर हमारा इंडेक्स का केसेस बनाएंगे, इंडेक्स मेरा और है, इंडेक्स मेरा एंड है, या फिर इंडेक्स मेरा
you
एक्सॉर
send
है.
in a 0. Now, whatever formula we made, for example, if your operand is, by the way, we are looking for the number phase. So we know number phase is initially 0, and all the ways you'll count, all the ways you'll count. And if you remember the DP, the recursion lecture 7, I told you whenever you're counting ways, if there is a one recursion call, two recursion call, you add up all of them. So these are recursion calls we made. You add up all ways. What does that mean? If you're counting all ways, first you'll try this and figure out the number phase and add it. Then you'll try this, figure out the number phase and add it. Then you'll try this, figure out the number phase and add it. Then you try this and this, figure out the number phase and you'll add it. Then you try this and this, figure out the number phase and you will add it. That's what you will keep on doing. So can I say, if this is what we have, as a very straightforward one, you say that, hey, listen, if the operand is somewhere and, if the operand is somewhere and, I know the ways will be nothing but, we just need true on the both sides. So left will be true and right will be true. Just please add them up. Similarly, you go on applying the formula for OR, and similarly, you go on applying the formula for XOR. Once you have done this, just the formula that we wrote, you return the total number of phase. Yes, you just return the total number of phase.
That's it.
That is what you'll do. Now, are we done? No. You have to be careful enough. Is this correct? No, this is not correct. Why is this not correct? Because this just gives you two ways. But if you remember, your function had a parameter. Does it want true? It might want false. It might want false. So on an and, if I'm counting, only if I want true, only if I want true, then I come across and do a true into true. What if I want false? Then the number of ways will be very simple. If I want false, it will be either one of them has to be false. So either the right one has to be false, or the left one has to be false, or the both has to be false. That will also work. So if the left is true and the right is false, it will give you a false. If the left is false and the right is true, it will also give you a false. If both of them are false, it will also give you a false. So if you're looking for false ways, this is how you count it. If you're looking for true ways, this is how you count it. Similarly for OR, you can write. Similarly for XOR, you can write, and you can just return the number of ways. That's how you do it. So we're definitely applying recursion, right? What are we applying? We are trying to apply recursion. And if you're applying recursion, the time complexity over here will be exponential. And in order to get it better, we will see if there are overlapping sub problems. And we will notice that there are overlapping sub problems.
Before coming to this, let's try and apply it by ourselves. Okay. There is a solve. There is S. There is 0. There is S dot LENGTH. Right. And there is true है मेरा ये. क्या है? Is true. This is what we want. Now, what it will give? It will give an integer. This is a string. This is I. This is J. And this is Boolean. Is true. Now, if I crosses J, right, we will just return 0. If I equal to J, that is our base case, the main base case. If is true, right, return S of I equal to 2. That is what we want. Else return S of I equal to false. Correct. Now we will initialize here a way is equal to 0. Now we will initialize our IDX from I plus 1 J minus 1. and we will hop it with +2. Okay, now we will be getting a right through. Okay, if we want right through, what we will give? We will give I if I'm right. It will be index right. Okay, left. If you want left through, we will do index minus. I say index minus h2. I say I'll do x minus 1. Correct. If you want left through, और यहाँ पे h2 होना through then integer letter तो हमें आप इसे idx minus 1 और यहाँ पे देना false integer right through अगर देना तो मैं I करूँगा x plus 1 x plus 1 j h2 through दे दिया right false x plus 1 j false दे दिया अरे यार ये मतलब solve 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 now if s of idx equal to or then यहाँ पे if is true then raise plus equal to इसमें proof कैसे कैसे होता है इसमें होता है तो इसमें होता है कि left true right true left true right true so lt into rt then we will do plus then left true भी हुआ left true हुआ और right false हुआ तो ही होगा और right left false into right true भी हुआ तो भी else raise plus equal to होगा left false into right false correct similarly else if s of idx equal to end so if is true then base plus equal to क्या होगा left true into right true and one else ये वाला अपन ले लेगा लेकिन इसमें बस लेफ्ट ट्रू राइट ट्रू की वजह लेफ्ट फॉल्स राइट फॉल्स करेक्ट है अब else if is true
So these are recursion calls being made. You add up always. What does that mean? If you're counting always, first you'll try this and figure out the number of ways and add it. Then you'll try this, figure out the number of ways and add it. Then you'll try this, figure out the number of ways and add it. Then you'll try this and this, figure out the number of ways and you'll add it. Then you'll try Try this and this, figure out the number phase, and you will add it. That's what you will keep on doing. So can I say, if this is what we have, it's a very straightforward one. You say that, hey, listen, if the operand is somewhere and, if the operand is somewhere and, I know the ways will be nothing but, we just need true on the both sides. So left will be true and right will be true. Just please add them up. That there are overlapping subproblems. Thereby, like you can draw the recursion tree and you'll see overlapping subproblems. Thereby, we can easily memorize it. Yes, thereby we can easily memorize it. And if you can easily memorize it, how do you memorize? You go back to the function at an I, the function at a j, the function as is true. All are changing parameters. I can be from 0 to n minus 1. So an n size will be required for the state. J can be from n minus 1 to 0. Again, an n size will be required. Is true, either I require true or either I require false. So there are two guys. So I'll be requiring a 3D dp of n, n, and 2. A 3D dp of n, n, and 2. And you will be just writing it over here like dp of I, dp of j, and is true is equal to ways. And similarly, you can just plug that in over here, right over here, yeah, right over here. If that dp has not been visited, you end up returning the dp of whatever is that. So just write across that. And if you're doing this, you will end up boiling down the time complexity to how many? You're using these number of states. N into n into these are the number of states that you're using. Inside every state, you're running a for loop for the partition to be made. So this is almost near about to n cube. Whatever the space complexity, you're trying to memorize it in n. Is that in over here? Right over here, yeah, right over here. If that dp has not been visited, you end up returning the dp of whatever is that. So just write across that. And if you're doing this, you will end up boiling down the time complexity to how many? You're using these number of states. N into n into these are the number of states that you're using. Inside every state, you're running a for loop for the partition to be made. So this is almost near about to n cube. Whatever the space complexity, you're trying to memorize it in n square into 2 plus an auxiliary because you're trying to shrink it down. So auxiliary stack space will be there. So this will be the time complexity and space complexity. In the next step, we'll try to code this up. So let's quickly check out the code. Now, something very important to figure this out is since the number of ways might be a lot of ways, you need to return the answer modulo this. Okay, so please make sure you take everything in long. Otherwise, it will be an issue. So please make sure you do this. int I, int j, and int is what we require, right? And you'll definitely require the string as well. So probably you can write the string as well. Perfect. Now I know one thing, if it exceeds this case will never happen, but still let's, for safety reasons, let's write it. And in this case, if I know it's is true, and I will then return expression of I is that true. If it is true, I'll return true, or else it goes as false. Else I'll return expression is equal to false. It's false, it's a one way because if I'm looking for that. Perfect. Right after this, I will have number phase. So just a quick thing, probably this we can do long, just to avoid overflows. Yeah, perfect. Long ways is equal to 0. For int index, the partition will start from this, and index will go until j minus 1, and index plus equal to 2. Perfect. And if I'm doing the partition, I'm looking for long left. Just instead of writing it again and again, let's do one thing. Hash define long is L. That is perfect. Let's change it to LL. Let's change it to LL. LL left true will be function of I of index minus 1. Let's find the number of truths. LL left false will be f of I comma index minus 1. Find the false. LL right true will be f of index plus 1 comma j comma find the number of truths. LL right or false will be f of index plus 1 comma j comma 0 comma expression. Okay, this is how you can easily find this off. Right after this, I know there can be two ways. One is the expression going to be AND. This is one of the ways. Else if the expression goes to be OR. That's another way. And the last way is definitely of XOR. If it is AND I know it is true is what I'm looking for, then I will go as ways plus right true into left true for sure. And we will do a modulo mod, and we will do a modulo mod over here. But if it is not, then I will do ways equal to ways plus. Then this will go as right true into left. I'm just looking for false. So right true into left false. Right true into left false. That will definitely give you false because you're looking for true, so it's just going to be 2 and 2. But if you're looking for false, true and false will give you false. Plus the right false into left true will also give you false. Plus both false will also give you false. Perfect. And if you're adding every one of them, just make sure after the addition, just do a simple one. Otherwise, it'll overflow. So false and true, false and true, and false and false. Everyone will give you a false. Perfect. If it's an OR, and if I'm looking for true, then I know it will be ways plus. If it's an OR, either left true into right true will give you a false. It will give you a true rather. I know the left true and the right false will also give you a true, and I also know a left a right true rather, or a left false and a right true will also give you a false. Sorry, a true. So all of these ways are bound to give you a true. But I'm looking for false, and the only way in which I can make it false is I take right false into left false, and I do a modulo mod. If I go across and do a modulo mod on both the sides, they both have to be false. Okay. Similarly for XOR, I know for XOR, if I just write down the ways, yeah, this is how it is. So if it is true, like if I'm looking for true, then the ways will be ways plus modulo for sure. And if I'm looking for true, I know both this and this will be true. So it will be left true into right false of modulo, perfect, and plus left false into right true of modulo. This is what it is. If it is not, then it will be ways plus. So either true and true will be false or false and false. So left true into right true, perfect, or left false into right false. Perfect. And you can just go and do a mod. Once you've done all of these, you can simply return the ways. It was a long one, isn't it? So over here, what you can do is you can just return f of 0 comma expression dot size minus 1 is n minus 1. I need true and I need the expression. Perfect. So this is what I'll write. And once you've written this, I think you'll be fine. I'll try running this. Hopefully it runs. It was a long code. I did not. Now this is recursion. We need to convert this into memorization. So simple step is vector, and you can just go on as LL, and then you can go as DP, and then you can go as N and then you can go as a double one, read it vector vector ll again, and then you can go the similar way when you can say n comma vector again, you can go in l, and over here you can go as 2 comma minus 1. I think it should be perfect. I'll just take it in the next line. Yeah, now it should be visible. So if you just do this, I think we should be fine, and now you can just pass on this. Just make sure you carry this. Amazing. So right at the next step, just make sure you DP. Right at the last step. Okay, my bad. Have a DP over here. Have a DP over here. So if you try submitting this, you will be seeing that you're getting a wrong answer. Okay, so we got a wrong answer. That is strange. Looks like you've done a minor mistake. This will be into. My bad. Okay. Yeah, apart from that, let's find it. We'll try submitting this and see if this is running fine. It does, it does. So guys, I hope you understood the memorization solution. So just in case you want to write the tabulation format, please follow the procedure that I've taught you right from the first in the DP series. There are 3 changing parameters. Just make sure you write them. Make sure you write the base cases by yourself. And right after that, just always the recurrence under the 3 nested loops. Maybe 4 nested loops. It'll get a lot complex. So let's not get deep into that. Instead of that, let's keep it simple to the memorization solution. But I highly appreciate if one among you can write the tabulation code by following the format that I've taught and put it in the comment section. That will be immensely helpful for a lot of other people as well. So yeah, with this, I will be wrapping up this video. Just in case you've understood everything, just give a like. And if you watched the video till here, let me know in the comments.
नहीं कर दिया 222 होगा हमारे नहीं मेरा matrix and the size is the largest submatrix. Sum is equal to 0. The size of the matrix is the product of rows and columns. Hmm. થોડુંક જ એકદમ રાધે રાધે. Okay, देखिए before summation. नहीं 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 बोली. राधे राधे.
In this video, we'll be discussing the problem largest submatrix whose sum is 0. So basically, we'll be given a matrix, and in that particular matrix, we have to find and print the matrix submatrix which is having sum as 0 and it has largest elements in it. So if you will see, basically we'll be given an n cross m size matrix and we have to find the largest submatrix. So in the whole matrix, we have to find the largest submatrix which is having the sum as 0. So before doing this problem, we need to understand one thing, that how to find subarray with zero sum, because if we want to
तेरे बस की बात नहीं हो रही। हाँ भाई, नहीं है मेरी बस की बात, तभी तो। मेरे बस की बात नहीं है, तभी तो पढ़ रहा हूँ ना मैं। प्रैक्टिस करते रहेंगे तो बस की बात हो जाएगी। पर वही है भाई, तुम जैसे लोग किसी को बिना सोचे समझे कुछ भी बोल देना। मतलब पैदा होते ही डीपी सॉल्व करने लग गया होगा तो शायद इसलिए कि हाँ भाई मैं निकला अंदर से, 2D एरे बना रहा हूँ, मेमोराइजेशन लगा।
Find a submatrix with zero sum. Here in this problem, you can observe that we want to find submatrix with zero sum. Correct. So we want to find what? We want to find submatrix with zero sum. Okay, with zero sum. Now, before that, we need to understand, like basically this is 2D. Since we need to find submatrix with zero sum, so this will be a 2D problem. Before solving that, we need to know how to find in 1D array, how to find a subarray with zero sum. Okay, subarray with zero sum. So in this problem, whenever we have to find subarray with zero sum, once we understand this problem, then the submatrix with zero sum problem will become easier for us, because here we'll be using the concept of prefix sum as well as the map. Okay, so firstly, what we'll be doing is, in this case, if you will observe, so in this case, what we'll be doing first of all is we'll be having, let's say we have an array, let's say 5, then we have got 10, okay, then we have got 2, then we have got something like, let's say -7, then we have got -5, then we have got, let's say 4, and then we have got 8. Okay, suppose we have got this as the array, and what we have as the sum is, let's say sum is there, and sum is given to us as like sum is like we will take the sum, that is the prefix sum. Okay, now what we will do is we'll also maintain a map, and why we will maintain a map, you will notice this, because like firstly initially the sum will be 5 only, then the sum will be 15. Okay, after that the sum will become nothing but 17, then the sum will be what? Then the sum will become 10. Okay, so as I keep on moving, I keep on adding the ith element inside my sum. Now after this, the sum will be what? 10 minus 5, which will be 5. Okay, then the sum will be 9, and then the sum will be how much? Then the sum will be 17. Now what can you notice here? The one thing that is noticeable here is that sum is repeating. You can see the sum here was 5, and again later on the sum became 5. So since I kept on adding the elements, still the same sum repeats. Okay, so this basically means that in between the subarray sum that is added, it must have been 0. So you can observe that this subarray basically is having how much sum? This subarray basically is having the sum as 0, because 5 after the first element 5, when we cumulatively add all the elements, that is 10, 2, -7 and -5, then you can see that the subarray is having sum as 0. That is why we see that repeated sum again. So since we saw 5 earlier, and now we are seeing 5 again, so this helps us to identify that there is a 1D subarray with 0 sum. Okay, now with the help of which data structure can we identify that whether a sum has been already seen or not? So with the help of map, we can easily identify whether a sum has been already seen or not. Okay, so basically what we can do is whenever we see a particular sum, we can store it in a map. Okay, and if we see that sum again, so then it basically indicates that the sum is repeating, which tells us that there will be a subarray with 0 sum, because in between the sum must have been 0. That is why that sum the sum is repeating. That is why 5 is repeating it. Okay, same logic will be applied when it comes to 2D matrix. Okay, we can easily identify whether a sum now repeated sum again. So since we saw 5 earlier, and now we are seeing 5 again, so this helps us to identify that there is a 1D subarray with 0 sum. Okay, now with the help of which data structure can we identify that whether a sum has been already seen or not? So with the help of map, we can easily identify whether a sum has been already seen or not. Okay, so basically what we can do is whenever we see a particular sum, we can store it in a map. Okay, and if we see that sum again, so then it basically indicates that the sum is repeating, which tells us that there will be a subarray with 0 sum, because in between the sum must have been 0. That is why that sum the sum is repeating. That is why 5 is repeating it. Okay, same logic will be applied when it comes to 2D matrix. Okay, when it comes to matrices, then the same logic is applied there as well. Because in matrices, what happens is, like in matrices also, whenever the sum will repeat, okay, then in such a scenario we can say that we have got submatrix with 0 sum. So let us quickly try and see the example. So suppose that if we write the second test case, so the second test case was what? The second test case basically was, let's scroll down and see. So the second test case basically was what? It was like 9. Then what we had was, so firstly we had 9, okay, then we had 7, okay, then we had 16, and after that we had 5. Okay, after this, what we have is we have 1, then we have -6, then we have got -7, and then we have got 3. So then we have 1, 8, and then we have got 7, then 9, and then 7, then -2, then we have got 0, and then we have got 10. So you can observe that this is the array. Let me just cross verify. 9, 7, 16, 5. Then we have got 1, -6, -7, 3. Then we have got 1, 8, 7, 9. Then we have got 7, -2, 0, and 10. Okay, so you can observe that the subarray, that is this particular subarray, this is having a sum as 0, because in this particular subarray, if you will observe, so the sum of the first two elements, like sum of -6 and -7 is how much? -13. Okay, then -2 will be -15, and 8 and 7 is what? +15. So overall sum is basically what? Overall sum is basically coming out to be 0. So that this is a sub matrix with 0 sum. Now how can we identify in this particular problem? Like how to identify? So So basically, what you can do is you can say that we can try to run for all the submatrices. Okay, so we will have a left pointer and we will have a left variable. Okay, and we'll also have a right variable. So left will indicate the current left column that I'm at, and right will indicate the current right column that I'm at. So suppose my L is here. Okay, and like initially my L will be here, R will be here. So this will be the leftmost and rightmost column. Okay, then after that what will happen? My left will be there, then my right will move. Then after that again my right will move. So leftmost column and then right column. Then after that R will move. So this will be the rightmost column. So left will stay there and right will keep on moving. By doing this, I'll be able to explore all the columns, that is 9117. Then I'll be able to explore the next matrix, that is 971 minus 6. That is this particular submatrix I'll be able to explore. Then once my R reaches further, then I'll be able to explore the sum is basically what? Overall sum is basically coming out to be 0. So that this is a sub matrix with 0 sum. Now how can we identify in this particular problem? Like how to identify? So basically what you can do is you can say that we can try to run for all the sub matrices. Okay, so we will have a left pointer and we will have a left variable. Okay, and we'll also have a right variable. So left will indicate the current left column that I'm at, and right will indicate the current right column that I'm at. So suppose my L is here. Okay, and like initially my L will be here, R will be here. So this will be the leftmost and rightmost column. Okay, then after that what will happen? My left will remain there, then my right will move. Then after that again my right will move. So leftmost column and then right column. Then after that R will move. So this will be the rightmost column. So left will stay there and right will keep on moving. By doing this, I'll be able to explore all the columns, that is 9117. Then I'll be able to explore the next matrix, that is 971 minus 6. That is this particular submatrix I'll be able to explore. Then once my R reaches further, then I'll be able to explore the submatrix which starts from the first row and ends at the which starts from the first column and ends at the third column. Right. So now in this case, if you will see, so one of the circumstances will be when my left is standing there. Suppose that my L is standing here. Okay, let's say our left is standing here and right will stand here. Okay, because basically you can understand that my left will start from here, left column will start from 0, and left will be, let's say, less than n. And then I'm going to do what? Then I'm going to do a left plus plus. Okay, then right will start from here. Right you can start from left. Okay, it's just like a nested loop. And then so basically we're trying to generate all possible column pairs. Right. So first row, like first column, first ending column. Right. Then first column, then second ending column, then first column, third ending column, first column, then fourth ending column, then second column, second ending column, like that. Okay, then right will be running and right will be less than n. Then we'll do a right plus plus. Now you can see that suppose this is my current left column, this is my current right column. Now after this, what we will do is we will have one array. Okay, so suppose I will declare one array, and in that array, what I will do is that array will be of that array's length will be equal to the length of the number of rows. So basically, from this left column to the right column, whatever elements are there, I will take their sum and in the corresponding row and store the sum. So basically, firstly you will see 7 and minus 6 are there. Okay, I'm just showing one of the instances of the driver. So you can see the sum will come out to be how much? 25. Okay, then if you see further, so sum of minus 6 and minus 7 would be how much? So for the next row, the sum of the elements from the leftmost column to the rightmost column, the sum will come out to be how much? The sum will come out to be nothing but, let's say, minus 13. Okay, then after that the sum will come out to be how much? Here the sum will come out to be 15. Then after that the sum will come out to be how much for the next row? From leftmost column to the rightmost column, it will come out to be minus 2. Now one thing that you can observe is if you look at this array, so if I write this array, okay, so this array is basically what? 25 minus 13, 15 and 2. So basically it is indicating the sum for each row from the current left column till the right column. Okay, the ith index is indicating that from the array. Okay, now if you take the prefix sum of this array, then what happens? So let us say that if you will take the prefix sum. Okay, let us say that if you will take the prefix sum here. So what happens if you will have a sum variable? Suppose that you will have a sum variable. So you already know what is your leftmost limit and rightmost limit. Now if you take the prefix sum, so in the sum, firstly you will have 25. Okay, so you will store that 25 is nothing at which index? Inside the map you will store that 25 is again at the 0th index. Then after that you will get what? You will get minus 13. So since you get minus 13, so your sum will become how much? It will become nothing but 12. So you are seeing 12 for the first time, you will update 12 with the index as 1. Then you will see 15. Since you see 15, so what you will do? You will update the data with 27. Okay, sum will become 27 and you are seeing it for the first time. So 27 will be updated with the index as 2. Then after that you will have 25 and 25 will be updated with the index like if you see 25. So when you see 25, so 25 is already there inside the map. So now you can say that since 25 is already there inside the map, so you will check the number of elements. So if you have a normal linear array, then the number of elements is r minus l plus 1. But since we are talking about 2D array, so here the number of elements will be nothing but, let's say, I minus mp of the sum that is repeating. So I is the current index, that is this particular index that is the third index. So minus mp of sum, that is this will give us 0 because 25 already was occurring at the 0th index plus 1. So this will be the number of elements r minus l plus 1. Like it is basically like r minus l plus 1 into down minus up plus 1. So that will give us the number of elements. If this number of elements in this submatrix, if it is greater than the number of elements, the largest submatrix that we have seen so far, then we will update our left-right range as well as leftmost column, rightmost column, as well as the upper row and the down column, down row. So that is what we need to update. So you can see here that basically when this subarray sum repeats, so what does it indicate? That here we are getting the sum as 0. So it indicates that from the index, that is from index mp of sum plus 1. Okay, that is from the 1th index, that is from the first row. Okay, that is from the first row till the ith row. We are getting the submatrix sum as 0. You can observe this submatrix is there, because you can see 25 was seen at the 0th index, then 25 is seen as the third index. So this means that from the 1th index till the 3rd index, from the 1th row till the 3rd row, the subarray is having 0 sum, and we already have our left and right fixed. So you can observe that how is the code running. So you can see that basically what is happening here is we have if you can see here clearly, so what happens is we have a left loop, okay, that is running for the left column. Then we have a right loop that is running for the right column. After that, we are also taking the sum of each array, okay, sum of each row, okay, sum of elements of each row we are taking from left to right, okay, from left to right, okay. Then after that, we are also, after this is over, then we ultimately take the prefix sum also, right? So you can observe that this is overall how much time complexity. If you see, so the first loop will be order of n time complexity. Second would be, let's say, order of n because we are running for the column. Second would be order of m as well. The third would be order of n, and the other one would also be order of n. So you can clearly see in this particular example so far that there are three nested loops, because these two loops, internal loops, that is prefix sum loop, and this firstly when I'm taking the sum of each row from left to right, that loop and the prefix sum loop in which I'm using the map as well, these two are running parallelly. So they are having overall complexity is order of n, and then we have m and m. So three nested loops, one inside the other. So the time complexity would be m into n. So this will be m square into n. So you can observe that the time complexity will come out to be how much? It will come out to be cubic in nature, that is m square into n. Okay. Now this is the logic for the question. Now let's really have a look at the implementation and let's see how I have implemented this code. Okay. So let me quickly show you the code part here. Right. So firstly, what I've done here is, if you will observe, so what I've done here is, first of all, like we have got this array, right? So we have got this 2D array, first of all, that is named as A. So firstly, I take the number of rows and the number of columns here. You can see I'm taking the number of rows and the number of columns. Once that is done, then I declare a temp array, okay? That is AR array that I was recommending for taking the sum of all the elements of a particular row from the leftmost column to the rightmost column. And I have declared variable that is f up, f down, f left, and f right. Now these variables all the elements of a particular row from the leftmost column to the rightmost column. And I have declared variable that is f up, f down, f left, and f right. Now these variables will help me to basically update the, like, these variables will help me to keep a track of the uppermost row, downmost column, leftmost uppermost row, downmost row, leftmost column, and the rightmost column. Okay. Now after that, I also have the sum variable, and I have up down because they will be varying. And I initially have initialized the maximum number of elements as int min. Okay, max L will tell me the number of elements in the current sum matrix that is having zero sum. Okay. Now what we are doing is we are running our left from zero. Left is less than column. Then we initialize our array to zero because we need to take the sum of all the elements from the current leftmost row, the current leftmost column till the current rightmost column. Okay. So that's why we are initializing our temp array or ARR array to zero. Then after that, what we do is, as I was indicating, for that particular row, for every row from left to right, we will iterate and we will find the sum of the elements. Okay. Now, like just like I was doing here, you can see this example. When I was doing it here, whatever is written in ARR, that will be done in temp. Okay. Once that is done, then what I need to do is I need to call a function. Let's say I will call the function as sum zero, although you could have written it here, but if you will write in terms of functions, then this will create more impact on the interview. Now what I will do with the sum zero function is, okay, now like just like I was doing here, you can see this example. When I was doing it here, whatever is written in ARR, that will be done in temp. Okay. Once that is done, then what I need to do is I need to call a function. Let's say I will call the function as sum zero, although you could have written it here, but if you will write in terms of functions, then this will create more impact on the interview. Now what I will do with the sum zero function is, like in this function I'm passing the array, okay, that is temp array, or you can call it as whatever is written in ARR, that will be done in temp. Okay. Once that is done, then what I need to do is, in from left to right, we will iterate and we will find the sum of the elements. Okay. Now like just like I was doing here, you can see this example. When I was doing it here, whatever is written in ARR, that will be done in temp. Okay. Once that is done, then what I need to do is I need to call a function. Let's say I will call the function as sum zero, although you could have written it here, but if you will write in terms of functions, then this will create more impact on the interview. Now what I will do with the sum zero function is, like in this function I'm passing the array, okay, that is temp array, or you can call it as ARR array also. I'm passing the up and the down. Up will indicate the upmost row, down will indicate the downmost row. Okay. These will indicate up will indicate the like upper row, and the down will indicate the downmost row for a row, for a matrix which is having zero sum. Okay. And I'm passing the number of rows as well. Now the Boolean value will the function will return a Boolean value indicating whether I found a submatrix with zero sum or not. Okay. And if I find that, then I already know my left and right because they're already fixed because of the two loops that I'm running one inside the other. And like since I'm passing up and down also with ampersand sign, that is passed by reference. So up and down, that is uppermost.
Hi guys, welcome back to the channel. I hope you all are doing good. So okay, we are going to continue with the DSA sheet. Many of you got scared, ready to run away. No, I'm here only. I will be doing the problems. And yeah, so today's video we will do an interesting problem and we'll finish up DP as soon as possible. Okay, so today's video is largest rectangular submatrix whose sum is zero. See, before trying to solve this problem, you go to my channel and go to my playlist, that is dynamic programming, DSA sheet topic dynamic programming, and then you watch this video. I'll just minimize myself. See, this video is the maximum sum rectangle. So if you first watch this video, then you know Kadin algorithm. Okay, you should also be knowing this one. How to find length of largest subarray with sum zero. So before solving this problem, it is better to have some prerequisite knowledge. Otherwise, this problem will look like a very, very new problem. Although in the video further, I will explain why am I telling you to have this prerequisite knowledge. Just first watch this if you haven't. But if you have, we can continue further. So what is the problem? We are given a 2D matrix and we have to find the largest rectangular submatrix with a sum equal to zero. Okay, so this is given as input over here. We'll take a smaller matrix to first of all identify. So suppose our matrix is something like this. Okay, so suppose this is our matrix. In this matrix, we have to tell the largest rectangular submatrix with sum zero. So if you carefully analyze and observe, you will get to know that this matrix here, I'll write this here now, 1, 2, 3, minus 3, minus 2, minus 1. Yeah, so this submatrix, see, if you find the sum of all elements here, what does it mean sum of submatrix? Find sum of all elements. So this is 6, this is minus 6, so 6 plus minus 6, 0, correct. Fine, so the sum is 0. And you can clearly check that this will be the largest one. What is the area? Area of this will be what? Length into breadth. Length is 3, breadth is 2, so it is going to be 6. Fine. So like this, see this question, they have asked us to print the matrix. So this is a little challenging, right? I mean, not so challenging also, but yeah, we have to print the matrix. So how can we print the matrix? We need to know where does the matrix start, where does the submatrix or where does our answer start. So we need to know starting row, we need to know the ending row, as well as we need to know the starting column and ending column. So if we know these these four things, then we can print our submatrix. Starting row, starting column, ending column. Four things are there. So these things we have to know. And also we should find the one which has largest area, because largest submatrix means largest area rectangle only. Fine. So here we will be using Cutting algorithm. How we use Cutting algorithm? The reason why I told you to watch this video, maximum sum rectangle, is because we have discussed the approach there, the Cutting algorithm approach. What is that approach? See, how we will be solving the problem is, see, this is a 2D matrix. We want to convert it to 1D array. Why we want to convert to 1D array? We can apply Cutting algorithm there. We can apply something like a Cutting algorithm. But in this case, instead of Cutting algorithm, we would have to know this algorithm. That is how to find length of largest subarray with sum 0. See, we have done many problems where we have done like a count subarrays with this sum. So there will be a target sum, right? There will be a target sum, and we have to count subarrays with this sum. So there will be a target sum, right? There will be a target sum, and we have to find a count of subarrays with this sum. So we have used the hashing, that is map concept, where we use the prefix sum and map to check if the prefix sum again occurs or not. All those things we have discussed, right? We have done many problems. So that is why you read this article also, how to find length of largest subarray with sum 0. What our approach is going to be, this matrix that is given to us, we want to convert this into a 1D array and then apply this one, find length of largest subarray with sum 0. Okay, so this article I'll put in description, you read it. So we want to convert, what does it mean convert to 1D array? It means, for example, if we are traversing the matrix row wise. So first row, these are the elements. This itself is a submatrix, correct? This itself is a submatrix, 1, 2, 3 matrix. This is a submatrix. Now, if I have to go to second row, it will be -3, -2, -1. And this is a submatrix. Instead of writing like this, what I will do, 1, 2, 3 is there, na? This row, all these elements, I will add it with the corresponding column element, column wise. So 1 plus -3, 2 plus -2, 3 plus -1. So what is that going to be? 1 plus -3 -2, this 0 and this 2. So this is going to be my transformed 1D array. So this 1D array, what is it actually representing? See, this 1D array, -2, 0, 2. It is representing this submatrix actually. I have just converted it by taking the summation. So now if I find out what is the length of the largest subarray having sum 0, if I get the answer as suppose 3 here, it means that in this submatrix I have found the length. I have found the length. See, if see over here, length of largest subarray with sum 0 is 3. You can clearly see now entire array only is having a 0 sum 0. So length of largest subarray with sum 0 is 3. It means that in this submatrix, length of the largest subarray with sum 0 is 3. So we have got length. We need breadth. How we'll get breadth? See, the starting row is I, ending row is j. So breadth is going to be j minus I plus 1. And length we have. So what is area? Length into breadth. So see, one problem is already solved. One part of the problem, length into breadth, that is done. That is why I told watch this video, maximum sum rectangle. We are converting every submatrix to a 1D array. So we can get length and breadth. I have shown you how to get length and breadth. I will take some more examples. See, what I'm trying to say is, some of you might not have understood yet. So I will take more examples. What we'll do, we are traversing the array. How? Row wise. We are traversing the array row wise. First we'll get this row. Then we go to next row. Instead of making this a 2D matrix, we will add each and every element to the corresponding column of our 1D array. We'll make only 1D array and we'll add it. So it becomes -2, 0, 2. So in this iteration, we will get this array. In the next iteration, what array we will get? In the next iteration, see, -2 plus 1, 0 plus 7. So it is going to be what? -1, 7, and 5 plus 2 is 7 again. So what does this represent now? -2, 7, 7. Sorry, -1, 7, 7. This 1D array corresponds to the entire 2D array. This entire 2D array, it corresponds to that. Like this, starting at every row I have to do. See, now I started at which row? At row 0, and I went on until last row. Now I will start from row 1. So initially my starting was this array. Now if I start from row 1, my starting array will be this, and I will build each and every array like how I told, add the corresponding column elements and make 1D array. So I'll start at each and every row and I'll make only 1D array, and I'll find the length of the largest subarray with sum 0. How to find that? First read this article. I've discussed this many times in the previous videos also. I think even in this video I've discussed with Cutting algorithm. I guess I have, or maybe in some other video, I'm not so sure, but I have discussed that map and frequency concept, prefix sum concept. Okay, so if you can observe here, this array, what we'll get? -2, 0, 2. What is the sum? Total sum only is 0. So length of largest subarray will be 3. And if we find out the breadth, we'll get the area. But now we have to do what? We have to print the matrix also. Suppose we have to print the matrix. Okay, now what will happen? We will have only 1D array like this. We will find out, okay, this is having max length 3, max length 3, max length of subarray having sum 0. This is the highest. So for that, we will find out where does it end? What is the ending index of the subarray? I want to know ending index of a subarray. This subarray ending index is going to be 2, because entire array itself is having some 0. So tell me one thing, if I know ending index and max length, can I find out starting index? Of course. How can I find starting index? It is going to be ending index minus max length plus 1. see, there is a starting point, some 0. So tell me one thing, if I know ending index 0, this is the highest. So for that, we will find out where does it end, what is the ending index of the subarray. I want to know ending index of a subarray. This subarray ending index is going to be 2 because entire array itself is having some 0. So tell me one thing, if I know ending index and max length, can I find out starting index? Of course. How can I find starting index? It is going to be ending index minus max length plus 1. See, there is a starting point, there is an ending point. The total is length. If you know end point and length, you can find starting point. Of course, what will it be? Ending point minus length plus 1. Why plus 1? Because it is zero-based index, as well as if there is a subarray like this. Okay, this plus 1 is saying that from this point to this point, we have the same subarray sum, which means that from the point which is 1 ahead of our initial point, from there, the entire sum will be 0. That is what it means. I'll explain this again. For example, see, if I take 4, 0, minus 4, yeah, if I take this, over here, in my map, I will store sum equal to index, which is 0. So map of 4 will be stored with 0. Here it will come and I will see, okay, what is the prefix sum till here? So till here prefix sum was 4, here also 4. Fine. Now I am getting to know that 4 is in the map. But where is the actual subarray starting? Where is the actual subarray with the sum 0 starting? With total sum 0, where is it starting? Not from here, from one index ahead. That is why starting point will be ending index minus max length plus 1. Because that is the starting point. Sum was 4, here also 4. Fine. Over here, in my map, I will store sum equal to index, which is 0. So map of 4 will be stored with 0. Here it will come and I will see, okay, what is the prefix sum till here? So till here prefix sum was 4, here also 4. Fine. Now I am getting to know that 4 is in the map. But where is the actual subarray starting? Where is the actual subarray with the sum 0 starting? With total sum 0, where is it starting? Point. From there, the entire sum will be 0. That is what it means. I'll explain this again. For example, see, if I take 4, 0, minus 4, yeah, if I take this, over here, in my map, I will store sum equal to index, which is 0. So map of 4 will be stored with 0. Here it will come and I will see, okay, what is the prefix sum till here? So till here prefix sum was 4, here also 4. Fine. Now I am getting to know that 4 is in the map. But where is the actual subarray starting? Where is the actual subarray with the sum 0 starting? With total sum 0, where is it starting? Not from here, from one index ahead. That is why starting point will be ending index minus max length plus 1. Because that is the starting point of my maximum length subarray. So first you read this article as well as you solve this problem, then this problem will be piece of cake. It will actually be piece of cake. So in this another example also, if you see here it is given that this is the matrix. It is already highlighted, right? So here what will we get? Our max length as 2. And breadth will be j minus I plus 1. So where is it ending? Where is the matrix ending? In which row? Third row. Starting in first row. Length will be 3 minus 1 plus 1, which is 3. Sorry, breadth will be 3 minus 1 plus 1. So area we will get. It is very easy to find out starting row and ending row. Starting column, ending column. For starting column, ending column, what you have to do? Just pause the video and think. Starting column, ending column is this only, na? Ending index is same as ending column. Index is not changing because whenever we take a 1D array is having same number of columns. Our 1D array will have same number of columns. So ending index is the same as ending column, and starting index of the subarray is same as starting column of our answer matrix. So time complexity over here, I guess it is going to be nmm. O of nmm, I guess. You can do the other way also, nm, whatever. So totally, I guess it will be n cube complexity. Okay, so first solve those two problems, this one plus this one. Solve those two. Now I'll show the code because coding this will take a long time. I'll show the code quickly. See, first is input r comma c. Okay, rows and columns. And now I have made some variables. Starting row, ending row, starting column. What is this ending column? This is going to be for finding my answer submatrix because I have to print the submatrix. See, here they are printed. They're printed. Output is the printed one, right? They printed it. So for that, I need to know starting row, ending row, starting column, ending column. Fine. Then I will make a matrix and I will take the input of whatever is given. Input. Fine. Okay. Now I have made a variable called final length, which will be the length of my final matrix. That length is there, that will be my final length. Now what I'm doing, for every iteration, for every row, I have to build the answer. That means, see, take this matrix, okay? This matrix, what I'm doing, 1, 2, 3 is one array, is one submatrix, you can say. Then like this, another submatrix. Then like this, another submatrix. Okay, so this was from first row starting. Now start from second row. -3, -2, -1. This is one submatrix. Then -3, -2, -1, 1, 7, 5. This is another submatrix. Some of you might question, hey, but why are you not taking submatrix like this? Why you're not taking this? So this will be already covered. If you find out a subarray having a length 2 only, if a subarray has length 2 and you know where it is ending and starting, then you will easily find out that this is only going to be the answer. So here we will take 1D array with a length equal to number of columns, but the answer can be anywhere in between. So don't worry about that. Don't get confused that why are we taking all the matrices of fixed number of columns. We will take that to maintain one 1D array. But our answer can be anywhere because our subarray can be anywhere, right? Just if you're getting confused with submatrix, transform it to subarray. Now subarray can be anywhere, and submatrix will be what? It only depends on number of. It only depends on the breadth. See how many rows are there. It depends only on that. It only depends on that, right? So that's why I said first solve this problem. Everything will be cleared. So that is what I'm doing here. See, for every row from that row I will go building, and I will take a array, current array, which will be my 1D array. That is what I was telling now. For every 1D array, I will do this only. I will send it to a function called subsum, subarray sum. Okay. And why is it returning a pair? It is basically returning maximum length of subarray as well as at which index it is ending. See, ending index is important here because ending index is going to be my ending column. Because my 1D array and matrix, the number of columns in matrix, that number, that C over here, this C.
Hi everyone, I hope you're doing well. So in this video, we're going to discuss Geeks for Geeks problem of the day, and today's problem is largest rectangular submatrix whose sum is 0, and it is a hard level problem. So the problem basically says that we have been given a matrix of dimensions n cross m, and we have to find the largest rectangular submatrix by area whose sum is 0. Right, now they have given us certain conditions. In case if our area is the same for multiple submatrices whose sum is 0, then in that particular case we have to return the one with the minimum column index, and then again if it is same, we have to return the one with the minimum row index. Right, these are certain conditions, but at the end you will realize that we will not have to worry about these particular conditions specifically because of the way we implement the problem. Right, now whenever we see these types of problems whose area is 0 or whose sum is actually 0 or whose sum is k, we resort back to a very standard problem that we have solved multiple times. So the standard problem that I'm talking about is subarray, find subarray whose sum is k, or in general whose sum is 0. Right, so what we generally do in this particular problem, we are falling back to the one-dimensional problem or the one-dimensional version of the today's problem. So what we generally do, let's say we have some values a, b, c, d, e, and let's say the prefix sums are p, q, r, s, t. So these are representing the prefix sums of the array, and this is the actual array. Now if I say that q is equals to t, that means c plus d plus e, the value, if I add these three values, this is actually equal to 0. Why? I'm saying that this particular value q is equals to this particular value t. This whole values p, q, r, s, t are the prefix sums. Now, if the prefix sum has not changed over the course of values, that means the values that are in between these places actually has the sum 0. Right? Similarly, if t minus q is equals to k, that means c plus d plus e is equals to k. So, like whenever you want to find the sum 0, this should be equal. If you want to find the sum k, that means the difference between these two prefix sums should be equals to k. So this is how we solve the one-dimensional array problem in O of n. What we do, we just traverse through the whole matrix, keep on storing the prefix sums in a map or any data structure we want, right? So we keep on storing this prefix sums in a map, and if we want to make the sum equals to 0, we just check whether this particular prefix sum was encountered before or not, right? So for example, let me just modify these prefix sum to look a little bit similar. So let's say this is P, Q, R, S and Q, right? So whenever I traverse the matrix, I will store P, first of all P in my map, then I will store Q in my map, and then I will store R in my map, then I will store S in my map. And when I come to this particular element, I see that Q is already present in the map. That simply implies that this prefix sum Q was also present somewhere before this particular point. That means there is a possibility that a sub-array sum is equal to 0, and that will be this particular sub-array in this range, right? So now we will try to extend this particular intuition to our current problem. So let me just draw a double dimensional array now. And even before that, let me just draw a column like this. So this is one single column, right? This represents this original array case, right? Now again, there are multiple ways to implement this particular problem, but I'm going to show you a way which I used. And for that, to understand that particular intuition, you need to first understand it with the help of a single column. So in this single column, if I want to find the rectangular submatrix, the rectangular submatrix whose sum is 0, I can apply the same logic I applied here, because both of them are single dimensional arrays. So let's say here prefix sum was P, then Q, then R, then S, and then again Q. I will know that this rectangular submatrix has sum 0 because this prefix sum is equals to this prefix sum, right? Now if I extend this single dimensional column into a multi-dimensional array like this, now let us see what will happen. So let's say this is some column 1 and this is some column 2, right? Now I can try to, let me draw it with a different color. So now if I go like this, so I'm taking a line. So now if I talk about this particular submatrix, right, what is essentially happening is, this is my current submatrix, right? Now instead of a single column, I have multiple columns here, right? So let's say this whole column, this whole row, that means this row consisting of this particular column had a sum, let's say P. These three cells had a sum Q, and these three cells had a sum again P, right? That means the sum of this particular subarray, that is these 6 cells, is actually 0, is coming out to be 0, right? Let me just explain you what I just said. So initially I had one column. Now I just stretched this particular column on both sides, so now it becomes multiple columns, right? Now let's say these 3 cells have the sum P, just similar to what I did here. This particular cell had a sum P, but since I've stretched it sideways, now instead of a single column there are multiple columns, and now these 3 cells have a sum P. Again these 3 cells have a sum Q, and these 3 cells have a sum P again. Now this means if this sum, or if this prefix sum was encountered before as well, that means the sum of this particular submatrix is equal to 0, right? So if I have some way of finding out the sum of this particular, each of these rows, right? So in this particular case, each row is having a single column, right? Each row is having in this particular case, each row is having 3 columns, right? So here it was a single column, here it is 3 columns. So in this particular case, when there was only one column, I was able to find the sum in O of 1, right? I was able to find the sum of this single cell in O of 1. If I am able to derive some way in which I can find the sum of these 3 columns in O of 1, then my overall complexity would be O of m into n. How is it like this? Because these two m's are used for fixing these 2 columns, right? Let's say my columns is fixed. Now this particular n is used to traverse the number of rows. So are you able to relate it to the first example that I took? So why? No, let us see how is it similar. So in this particular case, there was only one column, right? There was only one column, so this factor was never there. I never had to fix the starting and the ending columns. The only thing that I had to do was traverse to the matrix. Now this m into m factor is introduced because I want to fix column 1 and column 2. Let's say once I have fixed this column 1 and column 2, O of n time will be required to traverse to all the rows, right? Now if I am able to find the sum of these 3 cells in O of 1, then I will be able to stop my complexity till here only. Otherwise, let's say I'm not able to find the sum in O of 1, what I can do is I can multiply a factor of O of n again, and then I can find the sum linearly, right? But I want to avoid this factor because I cannot afford my complexity to go beyond this. That is why I will use prefix sum on the rows to find the sum of these three cells in like O of 1. Right. So this was the whole idea of the problem. I tried to give you an analogy and what we do when we have a single dimensional array. What difference did we make when we like stretched the array into multiple dimensions? The only thing that was introduced was this m into m factor, and that is because we want to fix at least one of the dimensions, that is the starting column and the ending column. And then this O of 1 is exactly similar to what we did in this single column case, right? So let me show you my code, what I've done. So I have I have stored the dimensions of the matrix n cross m first of all, and then I have created a row prefix and I'm taking it to be in one based indexing for proper understanding. Now I'm going through all the rows and all the columns, and row prefix of ij will be row prefix of ij minus 1 plus a of I minus 1 j minus 1. So this I minus 1 j minus 1 is only because this original a was in zero based indexing, right? Now what I have to do is, if you were not able to understand this part, let me explain this part again. This is the same row and I'm just referring to the previous column. So for each row I'm calculating the prefix sums, right? So what it will actually help me to do, it will help me to find the sum of these three columns in O of 1 or multiple columns in O of 1. This is the purpose of this row prefix. Now I initialize my best with 0 and sx xy and x xy and y, these are just going to denote the coordinates of the starting point and the ending point. Now again, using one based indexing, I'm fixing the starting column I is equals to 1, I is less than m plus 1, and I'm fixing the ending column as well, j is equals to I, because the ending column should start from at least this particular position, right? Now I'm creating a map which will store the prefix sums, right? Now my prefix of 0 is 0. This is what we generally do when we do in a single dimensional array as well. Why? Because if we do not take any elements, the prefix sum will obviously be equal to 0. Right. Now my current sum is also initialized with 0. Now I'm traversing through all the rows and adding the new sum to my current sum. So what I'm doing, row prefix of the kth row ending at the jth column minus row prefix of the kth row like I minus 1. Why I minus 1 is here? Because my columns are starting from I and I have to subtract I minus 1th row, I minus 1th column from it, so that the I minus 1th column is not included. So basically if I'm starting from column 1, I have to remove all the things till this particular column like this, right? So you see, I have taken everything in one based indexing. So even if I is the first column, I minus 1 will still be accessible. This was the reason to take one based indexing everywhere. So let me just write it, column I minus 1 will still be accessible. This was the reason to take one based indexing everywhere. So let me just write it in the comments here. So this loop is for the starting column, and the second loop is for the ending column. Let's say ending column, and this loop is for traversing through the rows, through the rows, right? Now what I do, if I have encountered this sum before, how can I check this? I can use pre.count. So pre.count will actually tell me what are the number of occurrences of this current sum in my map. If this is greater than 0, then what I'll do, I'll find my current area. So my current area will be equal to j minus I plus 1. Why j minus I plus 1? Because both j and I index are included. Both of these columns are included. Multiplied by k minus pre of C sum. Why am I not adding 1 plus 1 here? Because k is included, but this pre of C sum is not included. So in pre of C sum, I'm storing the first row in which this particular C sum appeared. Right. So I'm storing the index of the first row where the sum appeared, and that particular row is not included. That is why I do not add 1 here. Now if area is greater than best, then I update my best area and my
appeared, right? So I'm storing the index of the first row where the sum appeared, and that particular row is not included. That is why I do not add 1 here. Now if area is greater than best, then I update my best area, and my starting x will be 3 of c sum plus 1. My starting row is this particular value plus 1 because this row was not included. My starting column was I, my ending row is k because I'm at the current row k, and my ending column was j, right? Now if this is not found, I'll update my pre of c sum is equals to k. So you see, I'm updating this pre of c sum only when I'm encountering this particular sum for the first time. So this way what will happen, I will store the first row where this C sum appeared, where this particular sum appeared. So how this helps us? This will help me to find the smallest row, right? And obviously I'm starting my traversal for columns from the lower to the higher index. That is why I will also have the smallest column. This is what I said that when I said that this particular thing will be taken care of when we implement this particular problem. You see, I'm always taking the smaller column first, and I'm always storing the smaller row in my map, right? So this smaller row and smaller column conditions are always fixed, and I only update my area if my new area is greater than the best area, right? At the end, what I can do, I can initialize my answer vector. If best is equals to 0, then I can just return my empty answer vector. Otherwise, I'm going to start my traversal from the starting row till my ending row, and I will initialize my current row vector. So what I'll do, I'll start from the starting column till the ending column, and I'll push back this particular element I minus 1 j minus 1 into my current row. So again, this is the A was in zero based indexing. That is why I've done this. Now I will place back this whole row into my answer vector. At the end, I can just return my answer, double dimensional vector, and this would be my final solution. So let me sum
भाई हार्ड वाला प्रॉब्लम खत्म कर दिया भाई के सिस्टम है पूरा पूरा पूरा। थोड़ा कॉन्फिडेंस आया आज मुझे। यस। एटमोस्ट के टाइम वाला भी हो गया है। सबमिशन अभी अभी का होगा सर। सर सॉरी अबाउट दैट। भाई लास्ट दो सवाल बचे भी स्टैक्स एंड क्यूब्स। स्टैक्स एंड क्यूब्स एंड स्टैक्स एंड क्यूब्स एंड और इस पल में अल्लाह। और इस पल में एलसीएस का सवाल है। लॉन्गेस्ट कॉमन सब्सिक्वेंस का सवाल दे रहा रे। बस अगर मैं ए बी सी दूं तो जैसे मेरा बस एक बार ये देखो ए बी सी बस। तो क्या लो भाई। और इस पल में हम बस एक मैं हूँ, बस एक कदम है। बस इतना था, इतना दोनों ने शाम को चाहा, अंतर क्या दोनों की दोनों, अंतर क्या दोनों की चाह में बोलो, एक प्रेम दीवाने, एक तरस दाने, एक प्रेम दीवाने, एक तरस मकरादा, एक मेरा दोनों ने शाम को चाहा, अंतर क्या दोनों की चाह में बोलो, के प्रेम दीवाने के। दर 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 ना मैं जानूं ना तू जाने, जैसा है मौसम। चार पोच मुड़ाना उलड़ा लायो, चार पोच मुड़ाना મને દારૂડો પાયો રે, દારૂડો પાડ્યો એ પીધો. હે અરે પહોંચવા કે ને પગ મારા તું છે, મોડું થાય તો માથું મારું તું છે. ગોકુળિયો કોણ કોણ બાધા, વેચે નિરંગ ભીની રાધા. હે રંગ ભીલી રાધા ને લઈ બેઠી બાધા. ગોકુળિયો અરે ગોકુળિયો કોણ કોણ બાધા, વેચે નિરંગ ભીની રાધા. Hey, वो कुड़ियों कौन कौन बाधा na 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 na. Ooh. Boom, 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 boom. रंग बिनी राधा रंग बिनी राधा ने लाई बैठी बाधा चोर पोच मुड़ाना अरे गोकुड़ियो कौन कौन बाजना if LCS pa pa pam 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 कोई तो बता दे मुझे मैं क्या कुड़ियों कौन कौन बाधा LCS किधर है भाई लॉन्गेस्ट कॉमन सब सीक्वेंस इसका बस अपने को कोड उठा लेना ना हर बार की तरह कोड उठा लेंगे इसका उपसी उपसी आई मेड उपसी हर बार की तरह हाँ, हमने चॉपी कर लिया। यहाँ पे गए, ऐसे कर दिया। एक बार अरे कोकुड़ी अरे कड़ियों अरे हो रहा है वही बात बाबा कोकुड़ियों कौन बाता ये रंग देने वाला तेरे रंग में Okay. What are your lobi? Overall experience post qualification. Can I go back? हो इंटरल्यूड हो चंद्राय वक्रतुंडाय गौरी तनहाय चार पाच मुडाना फुलना लाया काय ग? हो अरे पोचवा के ने पग मारा रूखे रे मोडू થાય તો માથું મારું દુખે રે ભાઈબંધોએ દોસ્તારોએ ભાઈબંધોએ લતે લગાડી રે મધુરો દારૂડો મેં કેસે પીવે છે રંગ રાધા હે રંગીલી રાધાને લઈ બેઠી બાધા Pom 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 pom. Sululululululululululululu. Perde sulululu, perde sululululululululu. O कुड़ियों कौन दाता पीवे छे रंग भीनी राता ए रंग भीनी राता लई बैठी है। इसको क्या हो गया भाई? ये सब शॉर्ट बज गया था। फूल बनने गज कुड़ियों कौन बाधा एनी रंग भीनी राधा ए रंग भीनी राधा कुड़ियों कौन बाधा देखते हैं भाई क्या निकल के आता है हमारे नसीब में तू है कि नहीं मेरे नसीब में मैं हूँ कि नहीं ए दिल बेजाने मुझे बेजाने बस आखिरी
हेलो एवरीवन, वेलकम टू माय चैनल कोड स्टोरी विद माइक। तो आज हम अपने डायनेमिक प्रोग्रामिंग की प्लेलिस्ट का वीडियो नंबर 59 करने जा रहे हैं। और आपको पता होगा कि डीपी कंसेप्ट्स एंड क्वेश्चंस का प्लेलिस्ट अगर आप स्टार्ट करोगे तो वहाँ पर आप बेसिक से और एकदम स्टार्ट से डीपी
मुझे पता चलेगा कैसे करना है। नसीब में
सीख सकते हो, उसमें और वीडियोस आने वाले हैं। ओके,
तू है
तो आज का
कि
क्वेश्चन है लीड कोड नंबर 97,
नसीब
मीडियम।
तू है कि थ्री वेरिएबल मेमोराइजेशन करना है, इजी है, मैं बोल रहा हूँ। आई जे के लेके जाएंगे और अगर आई मेरा आई के बराबर हुआ तो ना के बराबर हो गया, नहीं तो फिर दोनों ऑप्शन में से कोई एक। ओ मुझे रात में वो मुझे मिल गया da 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 da
मार्क है क्वेश्चन, बट काफी सिंपल सा रिकर्शन और मेमोराइजेशन से ही बन जाएगा। और ऑलवेज रिमेंबर, जितने भी मैं रिकर्शन और मेमोराइजेशन से क्वेश्चन बना रहा हूँ, सबके बॉटम अप भी इस प्लेलिस्ट में आएंगे, डीपी कंसेप्ट क्वेश्चन की प्लेलिस्ट में, क्योंकि इस प्लेलिस्ट में हम सब कुछ समझ रहे हैं, बेसिक्स एकदम। ओके, तो आज की वीडियो रिकर्शन मेमोराइजेशन से बनाएंगे, ठीक है। और हम मेमोराइजेशन जब करेंगे तो 3 वेरिएबल का भी यूज करेंगे और 2 वेरिएबल का यूज करेंगे, दोनों तरीका मैं आपको सिखाऊंगा, ठीक है। क्वेश्चन नाम इंटरलीविंग स्ट्रिंग, काफी पॉपुलर क्वेश्चन है, ठीक है, बाय दीस कंपनीज। क्वेश्चन देखकर समझते हैं क्वेश्चन क्या। बहुत सिंपल सा क्वेश्चन है एक्चुअली में कि S1 S2 और S3 तीन स्ट्रिंग दे रखे हैं, आपको बस ये चेक करना है कि कैन S3 बी फॉर्म्ड बाय इंटरलीविंग S1 and S2, ठीक है। अब S1 S2 को इंटरलीव करने का मतलब क्या होता है वो देख लेते हैं। इंटरलीव करने पर S1 और S2 को अगर S3 आ गया तो आंसर ट्रू होगा, नहीं तो फॉल्स होगा, ठीक है। तो यहाँ पर देखो इसी से समझ लो, द इंटरलीविंग ऑफ टू स्ट्रिंग्स S and T का मतलब क्या हुआ, वेयर S and T are divided into n and m substrings respectively। जैसे S को मान लेते हैं आपने अलग अलग सबस्ट्रिंग में तोड़ लिया, आपका मन है कोई भी सबस्ट्रिंग में तोड़ सकते हो, T को भी बहुत सारे सबस्ट्रिंग में तोड़ लिया, तो इंटरलीविंग का मतलब ये होता है S1 plus T1 S2 plus T2 S3 plus T3 and so on, या फिर T1 S1 T2 S2 T3 and so on, ठीक है। यहाँ तक क्लियर है। तो देखते हैं कैसे सॉल्व करेंगे इसको। यहाँ पर S1 S2 S3 है, देख लेते हैं इसका आंसर क्या होगा। इधर से बहुत चीज़ें आपको समझ में आने लग जाएंगी, ठीक है। और ये भी पता करेंगे कि क्यों ये डीपी का क्वेश्चन है, पहला चीज़। दूसरा, इसको सॉल्व कैसे करेंगे अपना खानदानी तरीका, ठीक है, रिकर्शन एंड मेमोराइजेशन। ओके, तो यार सबसे पहले ये देखते हैं कि ये जो एग्जाम्पल है ना, इससे समझने की कोशिश करते हैं। देखो यहाँ पर ध्यान दो, ये मेरा S1 है, मान लेते हैं इसको मैंने ए में तोड़ लिया, बी सी में तोड़ लिया और सी में तोड़ लिया, तीन सबस्ट्रिंग में तोड़ लिया, ए बी सी और सी। और इसको मैंने दो सबस्ट्रिंग में तोड़ लिया, डी बी बी सी और ए में, यहाँ मैं लिख देता हूँ डी बी बी सी और ए में। अब देखते हैं S3 पर ध्यान दो, देखो यहाँ पर ए चाहिए, ए मिल गया, ठीक है, ए लिख देते हैं यहाँ पर। उसके बाद डी बी बी सी है ना, ये देखो यहाँ पर मिल जा रहा है मुझे, डी बी बी सी, ये S1 से मिला, ये S2 से मिला। उसके बाद देखो क्या है, बी सी है, तो बी सी मुझे यहाँ से मिल गया, बी सी ये S1 से मिला। उसके बाद ए है, ये ए मिल गया, ये किससे मिला S2 से। उसके बाद सी है, वो मुझे यहाँ से मिल गया, है ना, S1 से, सी S1 से मिल गया। तो देखो फिल करते करते सारा का सारा स्ट्रिंग S3 पूरा कंप्लीट हो गया है ना, ये पूरा कंप्लीट हो गया है। और इसका मतलब क्या हुआ कि हमने इंटरलीविंग करके ये पता कर लिया S1 plus S2 = S3 है, ठीक है। तो आंसर हमारा इसमें क्या होगा, ट्रू होगा। तो देखते हैं इसको अप्रोच में कैसे लेंगे, और उससे पहले ये समझेंगे कि भाई वाई डी पी। ओके, तो देखो इस एग्जाम्पल से समझो। यहाँ पर देखो S1 S2 और S3 है, तो देखो ऑब्वियसली बात है, जैसे मान लेते हैं S1 में मैं यहाँ खड़ा हूँ, आपको S1 और S2 को यूज़ करके ही तो बनाना है ना, देखते हैं कि आप S3 बना पा रहे हो कि नहीं, राइट। तो S यहाँ पर इंडेक्सिंग लिख देता हूँ 0 1 2 3 4 0 1 2 3 4 0 1 2 3 4 5 6 7 8 9। अच्छा, एक चीज़ तो पहले ही मैं लिख देता हूँ कि अगर S1 का जो लेंथ है, अगर S1 का लेंथ और S2 का लेंथ, दोनों का कैरेक्टर पूरा यूज़ करना है, और दोनों का सारे कैरेक्टर यूज़ करने के बाद वो S3 के बराबर होना चाहिए। अगर इनका लेंथ नॉट इक्वल टू S3 डॉट लेंथ हो गया, तो ऑब्वियसली बात है, पॉसिबल ही नहीं है कि उनको मिला के आप S3 ले आओ, तो उस केस में तो रिटर्न फॉल्स करना ही करना होगा। ये मैं पहले ही लिख देता हूँ क्योंकि ये तो बड़ा बेसिक सा चीज़ है, क्योंकि तो आपको सारे कैरेक्टर
मुझे रात में ओ दिल ही जाने, ओ दिल ही जाने, do not to see the way to mix the character to form a nation of मैं प्यार बरस गया मेरे तने जो भी जाने आकर मेरे नसीब में तू है कि नहीं किया मेरे नसीब में तू है कि नहीं अरे यार क्या कर रही हो क्या कर रही हो क्या कर रही हो फूल सा खिल गया मेरे तने बस कैसे कैसा वो मुझे मिल गया है है दते आशिकी जगह खैरों से सवे जगह है दते आशिकी जगह भरोसे अबे यार ये क्या कर दिया अगर समझाना जरूरी है कि मुझे मिल गया तो दिल ही जाने न जो ही जाने है इसलिए ये आकर तेरे नसीब में छू है के नहीं मेरे नसीब में तू है तू है के नहीं रा 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 हो गया ना ला 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 ला
यूज कर भले आप इसको इंटरलीव करके करो या जैसे भी करो सारे कैरेक्टर चीजों में ऐसा शुरू मैं ये चेक करना कि स्ट्रिंग मिल पा रहा है होगा कैरेक्टर को ठीक है तो ठीक है मैंने क्या किया S1 से ले लिया
बाबा
ए को ले लिया और फर्दर एक्सप्लोर करने बोल दिया कि फर्दर देख लो आगे आंसर आता है कि नहीं ठीक है तो आई आगे बढ़ गया फर्दर बच गया इतना पार्ट ठीक है और सिंस ये ए और ये वाला
हरदर 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 हरदर
ठीक है
हरदर हरदर हरदर
तो मैं S2 पर ए है ये ना यहाँ पर है ना और के भी आगे बढ़ गया
मैनू चढ़िया
मान लो तो ठीक है तो देखो ऑब्वियसली बात है क्या होगा आई यहाँ पे खाली है ठीक है और ये क्या है के यहाँ पर देखो ये मैच कर जाएगा इससे आई यहाँ गया के यहाँ गया ये मैच कर जाएगा इससे आई यहाँ गया के यहाँ गया ये से मैच कर गया के यहाँ आई यहाँ तो देखो आई और के आउट ऑफ बाउंड हो गया राइट बट देखो जे तो कभी आउट ऑफ बाउंड हुआ ही नहीं ना क्योंकि जे S2 हमेशा एम्प्टी था तो इस केस में क्या होगा आई इज इक्वल टू एम हो जाएगा एंड एन जे इज इक्वल टू एन नहीं होगा ना, ये गलत हो जाएगा, एंड के इक्वल टू एन होना, मतलब ये तीनों साथ होता तभी आंसर ट्रू होता, बट यहाँ पर ऐसा हुआ ही नहीं, तो ये मेरा कंडीशन मीट नहीं होगा, ठीक है। बट ध्यान दो के मेरा आउट ऑफ बाउंड हो चुका है।
पर अगर तुम देखो S2 का लाइन 0 है तो J इक्वल टू 0 ही होगा, तुम 0 से इनिशियलाइज करोगे तो
आई नो के आउट ऑफ बाउंड हो चुका है, के आउट ऑफ बाउंड हो चुका है, मतलब क्या हुआ कि आपको सारे कैरेक्टर्स मिल गए होंगे, बट देखो सारे कैरेक्टर्स इधर से ही मिले, इंटरलीव होकर मिले नहीं है S2 से, तभी तो देखो S2 अभी भी यहाँ खड़ा है, ठीक है। यहाँ तक क्लियर है। इसका मतलब क्या हुआ कि चल मान लिया कि के मेरा आउट ऑफ बाउंड हो गया है, बट वो ये तीनों कंडीशन मीट नहीं हुआ है, तब मेरा रिटर्न फॉल्स कर दूंगा, ठीक है। के इक्वल टू आउट ऑफ बाउंड मतलब क्या हुआ, सारे कैरेक्टर्स मिल गए, बस सारे कैरेक्टर्स मिल गए तो वो सारे कैरेक्टर्स इनसे उनसे दोनों से मिलने चाहिए, मतलब ये भी आउट ऑफ बाउंड होना चाहिए, ये भी आउट ऑफ बाउंड होना चाहिए, ठीक है। जैसे इसका मतलब ये हुआ, ठीक है। अगर ये इन दोनों में से कोई भी ट्रू नहीं है, सिर्फ ये ट्रू है, यानी कि अगर अब के इक्वल टू एन हो जाता है, ये तो ग्रेटर देन तब मैं रिटर्न फॉल्स करूंगा कि यहाँ पर ये फॉल्स क्यों होगा। इसका देखो मैं यहाँ पर मेरे पास ऑप्शन है, ठीक ठीक या दोनों में से कोई एक, तो उस केस में रिटर्न फॉल्स कर दो, यहाँ तक क्लियर है। इसके बाद मेरे पास में दो ऑप्शन है, ठीक है, कि मैं या तो S1 का ith लूंगा या S2 का jth कैरेक्टर लूंगा, दोनों ऑप्शन ट्राई करूंगा, ठीक है। तो मैं लिख लेता हूँ यहाँ पर कि मैं टेक ith कैरेक्टर लिया S1 का, बट ये कब लूंगा, जब वो बराबर होगा कैरेक्टर S3 के kth कैरेक्टर से, तभी तो ले सकता हूँ ना, ऑब्वियस बात है। तो मैं यहाँ ऐसे लिख देता हूँ कि तभी मैं ले पाऊंगा, अगर ये दोनों बराबर है तब मैं निकाल पाऊंगा, जे वही का वही रहेगा, के भी बराबर हो गया ith से, तो के भी आगे बढ़ गया। अब आगे एक्सप्लोर करके जो आंसर S3 का kth कैरेक्टर के लास्ट में मैं क्या कर दूंगा, रिटर्न रिजल्ट, ठीक है। बड़ा सिंपल था ये तो, किसी से भी आंसर आ जाए मेरा बात बन जाएगा, हो सकता है इसको कॉल करने से इधर से रिटर्न कर सकते हो, तो पड़ेगी 3 तो एक
बेबी भी
निकाल
बच्चा के
तो जल्दी से इसको फिनिश
बैटिस कर रही गोश्ती में
पूरी यूज होगी। दूसरा पहले आइए एक्सप्लोर करके आगे का देख। सिमिलरली मैंने क्या बोला, दूसरा भी ट्राई मार लेते हैं कि अगर S2 का j कैरेक्टर S3 का k कैरेक्टर बराबर हुआ तो i तो वही रहेगा, j आगे बढ़ जाएगा j+1, जहां से भी रिटर्न ट्रू आ जाए मैं रिटर्न रिजल्ट कर दूंगा, जहां से भी रिटर्न आ जाए, इससे ट्रू आ गया तो यहां से रिजल्ट ट्रू आ जाएगा, नहीं तो इसे, या तो हो सकता है मैंने क्या बोला कि मैं ट्रू कहीं से भी मिल जाए, अगर यही पर आपको रिजल्ट इक्वल टू ट्रू मिल गया तो इधर से रिटर्न कर दो ना, रिटर्न ट्रू है ना, रिटर्न रिजल्ट, उसके बाद एक्सप्लोर कर लो, मतलब मुझे आंसर ट्रू चाहिए, अगर मिल गया तो रिटर्न कर दो, नहीं तो दूसरे वाले को एक्सप्लोर कर लो, ठीक है। बिना मेमोराइजेशन पहले सबमिट करके देखते हैं, एंड लेट्स सी विदाउट मेमोराइजेशन इफ यू आर एबल टू पास ऑल द एग्जांपल टेस्ट केसेस, और सबमिट करके देखते हैं। कंस्ट्रेंट छोटा है, मुझे लग रहा है कि शायद ये एक्सेप्ट हो जाएगा, मैंने बहुत पहले इसको सॉल्व किया था, हो सकता है टेस्ट केसेस बदल दिए गए, हो सकता है टाइम लिमिट हो जाए, इंडियस टाइम लिमिट हो गया तो मेमोराइज करने की बारी आ चुकी है। सबका लेंथ देखो 100 दे रखा है ना, S1 और S2 का लेंथ 100 दे रखा है, और S3 का 200 दे रखा है, ठीक है। ऑब्वियस बात है S3 का 200 मतलब S1 या S2 से डबल ही होगा साइज, है ना, क्योंकि S3 का बनता है S1 S2 को जोड़कर बनता है, ऑब्वियस बात है S3 का लेंथ जो है ना वो 200 200 से कम होगा, तो इंट t 101 S1 के लिए 101 S2 के लिए, और S3 का तो वो ट्रू हो जाएगा, और अगर यहाँ से 0 याद है वो पॉसिबल थोड़ा सा
ओल्ड
और
स्टोरी विद
देखना
माइक से
देखना
पढ़ना भाई,
ये
अच्छे
सिंगल
पढ़ा
मतलब से दो ही वेरिएबल बन जाएगा, हमें के का ट्रैक रखने की जरूरत नहीं पड़ेगी, ठीक है। तो चलो उसको भी देख लेते हैं, उससे भी सबमिट करके देखेंगे, ओके। तो देखो एक्चुअली टू वेरिएबल मेमो एकदम ऑब्जर्वेशन बेसिस पर है, अगर आपको ऑब्जर्व हो गया तो अच्छी बात है, नहीं तो दैट्स टोटली फाइन, ठीक है। हमने नॉर्मल जो खानदानी तरीका होता है मेमोराइजेशन वो हमने कर लिया, उस पर देखो स्लाइड ऑप्टिमाइजेशन ऑब्जर्वेशन है मेरा, कि मान के चलते हैं मैं ना यहाँ पर पहुंच गया हूँ कि मैंने ए और डी बी बी सी बना लिया है, ए कहाँ से उठाया था, यहाँ से, तो आई यहाँ पर रहा होगा क्योंकि ये और ये तो मिल गया होगा, राइट, ठीक है। और उसके बाद डी बी बी सी है ना, डी बी बी सी कहाँ से मिला होगा, यहाँ से मिल गया होगा, तो जे यहाँ पर रहा होगा अभी, है ना, ये सारे मिल गए होंगे मुझे, और आगे बढ़ गया होगा, तो ए डी बी बी सी देखो यहाँ बन चुका है यार, ए डी बी बी सी। तो देखते हैं जे पर यानी कि मैं कहाँ तक पहुँच गया हूँ, ए डी बी बी सी इतना तक पहुँच गया हूँ, ठीक है। तो याद करो जब हमने फर्स्ट जो सोल्यूशन था हमारा उसमें के हमारा यहाँ पर रहा था, राइट, के का वैल्यू क्या 6 है, 6 इंडेक्स पर है, तो आप खुद सोचो आपको के रखने की जरूरत है क्या, आपको के रखने की एक्चुअल में जरूरत नहीं है, रीजन बताता हूँ, देखो रीजन क्या है, एट एनी पॉइंट ऑफ टाइम आई यहाँ पर है और जे यहाँ पर है, इसका मतलब क्या हुआ, जे से पहले जितने कैरेक्टर्स थे और आई से पहले जितने कैरेक्टर्स थे वो हमने ले लिए हैं यहाँ पर, यानी कि यहाँ पर कितने कैरेक्टर थे 4, यहाँ पर कितने कैरेक्टर थे 2 4 तो 6, मतलब 6 कैरेक्टर हमने यहाँ ले लिया था, 1 2 3 4 5 6, तो 6 कैरेक्टर ले लिया, मतलब अभी मैं पक्का 7वें कैरेक्टर पर खड़ा हूँ, 7वां कैरेक्टर मतलब 6 इंडेक्स पर खड़ा हूँ, यानी कि आप आई और जे से ही पता कर सकते हो के की वैल्यू क्या होगी, पता क्या होगा, सिंपल आई प्लस जे होगा, सिंपल आई प्लस जे होगा, तो आपको के का ट्रैक रखने की जरूरत ही नहीं है, ये चीज समझ में आ गई। आप कोई भी आप किसी भी स्टेट पर आके देख लो ना, आप कोई भी पोजीशन पर आ जाओ, आप देखना हर वक्त के की वैल्यू आई प्लस जे के बराबर होगी, एंड इट मेक सेंस आल्सो, अभी मैंने आपको दिखाया भी क्यों, है ना। तो ऑब्वियसली बात है, देखो यहाँ पर जहाँ जहाँ के है मुझे वहाँ के ना लिख के को हटा दो, इधर के की जरूरत ही नहीं है, अब जहाँ जहाँ के है वहाँ बस आई प्लस जे लिख दूंगा मैं, तो देखो मुझे के से कोई मतलब ही नहीं है अब, आई प्लस जे, है ना। यहाँ पर भी के ना लिखे, हर जगह के जहाँ जहाँ था ना वहाँ आई प्लस जे लिख दूंगा, ठीक है। के की तो जरूरत ही नहीं है और पास ही नहीं करूँगा मैं कुछ भी, और जहाँ जहाँ के था वहाँ पर आई प्लस जे होगा, ये चीज समझ आ गया, क्योंकि आप जब आप ड्राई रन भी करोगे ना एट एनी पॉइंट ऑफ टाइम आपको हमेशा आई प्लस जे के बराबर ही दिखेगा, और बहुत बेसिक सी चीज भी है, क्यों ऐसा हुआ है, क्योंकि मैं हमेशा इनसे या तो इनसे कैरेक्टर उठा के ही यहाँ आगे बढ़ रहा हूँ, यानी कि आई और जे पर ही डिपेंडेंट है कि के का इंडेक्स क्या होगा, S3 पर के की वैल्यू क्या होगी, इंडेक्स क्या होगा, ठीक है। बहुत सिंपल है, तो चलो सेम कोड में जाते हैं और उसको ये कर लेते हैं, चेंज कर देते हैं, ठीक है। तो अब हमारा डीपी अरे सिर्फ 2 होगा ना, 2 इंडेक्स का होगा, 2 डायमेंशन का होगा, एक आई के लिए एक जे के लिए, ठीक है, यानी कि 101 और 101, ठीक है। और मैक्सिमम सिर्फ 2 स्टेट्स में विजिट करेंगे, सॉरी इतनी स्टेट्स में विजिट करेंगे, यानी कि m क्रॉस n अब मेरा टाइम कंप्लीट हो जाएगा, ठीक है। तो चलो जल्दी से कोड को मॉडिफाई करके सबमिट कर लेते हैं। तो देखो जरा भी मेहनत करने की जरूरत नहीं है, हमें बस क्या करना है, के को गेट रेट करना है ना, तो यहाँ पर के के लिए अलग से वेरिएबल की जरूरत ही नहीं है, ठीक है। यहाँ पर भी के भेज देते हैं, इसको भी हटा दो, ठीक है। टाइम कम्प्लेक्सिटी भी ये हट जाएगा, सिर्फ 2 ही है, ठीक है, m इंटू 1 का टाइम कम्प्लेक्सिटी, और यहाँ पर के की जगह बस आई प्लस जे कर दो, ठीक है। यहाँ पर भी के की जगह बस आई प्लस जे कर दो, जहाँ जहाँ पर इसको तो हटाई दो क्योंकि मेरा जो 2D अरे है डीपी अरे वो सिर्फ 2 डायमेंशन का है, यहाँ पर के की जगह आई प्लस जे कर दो, ठीक है। यहाँ पर के को हटा दो, के पास ही नहीं कर रहे हैं, ये भी हटा दो इधर, यहाँ पर भी के को हटा दो, और यहाँ पर के की जगह आई प्लस जे कैरेक्टर होगा S3 का, इधर भी इसको हटा दो, यहाँ पर भी इसको हटा दो, होपफुली अब रन हो जाना चाहिए, लेट्स सी इफ यू आर एबल टू पास ऑल द एग्जांपल टेस्ट केसेस फर्स्ट, उसके बाद इसको सबमिट कर लेते हैं, लेट्स सी। Indeed, yes, we have solved this question. We have passed all the test cases using only 2-dimension memorization. ठीक है, कोई भी डाउट होता है, raise in the comment section. I'll try to help you out. See you guys in the next video. Thank you. सो हेलो गाइस, आज फाइनली ये टाइम आ गया है जब मैंने आई गॉट सम टाइम टू मेक एन अनबॉक्सिंग वीडियो ऑफ द यूट्यूब सिल्वर बटन। तो ओपन करते हैं। ओके, इट लुक्स गुड। तो सबसे पहले छोटी सी कार्ड मिलती है बॉक्स के अंदर, ये बताता है कि अवार्ड को रिक ने केयरफुली इंस्पेक्ट करके पैक किया है। सो थैंक यू सो मच रिक, आई हैव गॉट इट सेफ एंड साउंड। अब आता है, ये काफ़ी इंटरेस्टिंग पेज लगा मुझे। यूट्यूब बोलता है कि अगर आपके साथ कोई टीम ने काम किया है तो उनके लिए भी पर्सनलाइज अवार्ड आप अलग से ऑर्डर कर सकते हो इन लोगों को, ठीक है। अब आते हैं दिस लेटर फ्रॉम यूट्यूब CEO नील मोहन। और इसमें ये लाइन मुझे बहुत ही अच्छा लगा, डू यू रिमेंबर योर फर्स्ट सब्सक्राइबर। तो एक्चुअली मैं फर्स्ट 100, 500, 10,000, 50,000, 100,000 सभी याद है मुझे, एंड हर कुछ याद है, सब कुछ लिटरली हर एक माइलस्टोन याद है। ये लेटर सिर्फ एक कागज़ नहीं, एक्चुअली मैं पूरी जर्नी का रिफ्लेक्शन है, टू बी वेरी ऑनेस्ट, एंड काफ़ी अच्छा लगा मुझे पढ़कर।
The reunification of North and South Korea is not just about two nations. It's about a united people, a shared.
और फाइनली ये रहा हमारा सिल्वर प्ले बटन फॉर 100K सब्सक्राइबर्स। सो जब शुरू किया तो बस एक आइडिया था, एक ड्रीम जैसा था। मैं पता था कि जर्नी इजी नहीं होगा, वीडियो बनाना, कभी कभी लेट नाइट उठना, एडिट करना, कभी वीडियोस फ्लॉप हो जाना, सोचना कि यार सब छोड़ो, बहुत मुश्किल हो जाता कई बार ऐसा। तो लेकिन आप लोगों ने हर बार मोटिवेट किया, कमेंट किया, शेयर किया, और आज ये मोमेंट पॉसिबल बनाया। एंड टू बी ऑनेस्ट, आपके जो कमेंट्स होते हैं, दे मोटिवेट मी अ लॉट। दे आर एक्चुअली अ ड्राइविंग फैक्टर, दे आर द ओनली ड्राइविंग फैक्टर टू बी to work even harder, to improve myself, to work on myself. Nobody's perfect, I'm not perfect. Everyone is working hard to get better, and that's what I am doing, that's what I will keep on doing. And ये सिर्फ एक अवार्ड नहीं है, ये प्रूफ है कि कंसिस्टेंट मेहनत और सच्चा कनेक्शन लोगों तक जरूर पहुंचता है ना। इसमें सिर्फ चैनल का नाम लिखा है, बट इसमें आप सभी का हिस्सा है ऑनेस्टली। ये हमारी जर्नी का एक माइलस्टोन है, एंड दिस इज जस्ट द बिगिनिंग, राइट? एंड लेट्स सी व्हाट फ्यूचर होल्ड्स फॉर ऑल ऑफ अस। थैंक यू यूट्यूब, थैंक यू एवरी वन ऑफ यू, थैंक यू सो मच। हेलो एवरीवन, वेलकम टू माय चैनल कोर्स विद माइक। तो आज अपने गाइडेंस क्वेश्चन एंड आंसर के प्लेलिस्ट का पार्ट 6 करने जा रहे हैं, और ये वीडियो स्पेशल होने वाला है क्योंकि 100 के हमने जस्ट अभी कवर किया है, ये उसी पर वीडियो है, ठीक है। सो दिस इज गोइंग टू बी 100K स्पेशल वीडियो, 100K पीपल, 100K लर्नर्स, 100K स्टोरीज कनेक्टेड बाय वन थिंग, एंड व्हाट इज दैट वन थिंग? लव फॉर प्रॉब्लम सॉल्विंग एंड बिलीफ इन ग्रोइंग टुगेदर। ओके, तो चलो स्टार्ट करते हैं। लेट्स टेक अ पॉज एंड लेट मी टेल यू माय स्टोरी। थोड़ा सा रुकते हैं और देखते हैं कि मेरा पास्ट कैसा रहा और क्या क्या लाइफ में इवेंट्स हुए। कुछ इवेंट्स मैं डिस्कस करूंगा, सारी इवेंट्स डिस्कस करना पॉसिबल नहीं है, ठीक है। तो क्या क्या वैसे इवेंट्स हैं जिसकी वजह से मेरी लाइफ में चेंज आया, जिसकी वजह से मैं इंपैक्ट हुआ, क्या चेंजेस आए, वो सारे
pam 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 pam. Reverse string using stack boys. Stack boys. Boo boo babu. Boo 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 babu boo ba boo babu ba. Kong kong king kong king kong king kong 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 king kong king kong king kong 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 king kong king kong king kong 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 king kong 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 king kong king kong king kong 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 mm, 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 mm. Con tin con tin con Snakes. Really, ये मैंने सॉल्व ही नहीं किया था कभी सच में design a stack that support operations like push pop 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 pop. 咚咚咚咚咚咚咚咚咚咚咚咚咚咚咚咚咚。咚咚咚咚咚咚咚咚咚咚咚咚咚咚咚咚咚。18 आया फिर सॉरी 19 आया कितना है आपका ये दोनों छोटे बिना 29 है लेकिन 19 और 18 छोटे छोटे स्टैक में 20 स्टैक में डाला स्टैक में Let it rapper it down, it down, it down. Let it rapper it down. Kicks, what? सरर होता चले स्कूल क्या है स्कूल का क्या करूँ मैं हाँ स्कूल क्या होता है मुझे क्या पता रेंज कितने रख सकते हैं कुछ तो वैल्यू प्रोवाइड करो कि इतना ही होना चाहिए लेंथ कहीं लिखा नहीं है कैसे करूँ मैं स्कूल यारी तेरी यारी चल माना इस बारी सारी तेरे फिक्र तेरे आगे आके हारी हम्म, चल माना इस बारी ये सारी तेरी फिक्र तेरे आगे आके हारी यारी तेरी यारी टॉप पॉप कसम करते पॉप पॉप है वतन वतन मेरा बाजे से है तो से आते सीना है से आते यारी तेरी यारी चल माना ये लो parking yellow, parking yellow, parking yellow. fucking yellow, fucking yellow, fucking yellow, fucking yellow. This full time implementation क्या होता है? क्या आता है इसमें? वाह, गंदे. If or or stuck, stuck, secret tertena, secret terten. Barking yellow, barking yellow, barking yellow, 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 yellow. Stop, 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 chuck. MS, MS, yeah, yeah, Jamal. Barking yellow, barking yellow, barking yellow, barking yellow, barking, 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 barking. यारी तेरी यारी सलमाना इस बारी 230 हो गए हैं. 230 questions done. Boys, 230. शुरुआत काफी धीमी थी क्योंकि डीपी पे थे. फिर शुरुआत तो क्रेजी से हो गई क्योंकि हम सीरीज पे आ गए. ओके, चलो फटाफट 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 मिलेंगे हम आपको. अब कल 230 सवाल डन हो गए. 230 समझ रहे हो? तो मजा आ गया. चलो मिलते हैं. सी यूज एंड